And Marc-André, we'll let him introduce himself. Can we have Marc-André on the screen? Marc-André, you there?
Hello. How are you guys? I'm not sure if I'm on screen somewhere, but anyway, I think you can hear me.
Marc-André, are you an angel or something? Like, I just hear your voice. What's going on?
I am an angel. Je suis un ange, oui.
So introduce yourself, Marc-André. Introduis-toi un petit peu.
Oui, je suis ici.
OK, il est là. All right. So Marc-André il fait partie de Brilliant Labs aussi, le labo créatif. Et lui, il va s'occuper des présentateurs en ligne, car on va avoir des présentations en ligne. Alors aujourd'hui, on va voir plusieurs présentations de vos travaux, de vos réalisations. We'll see a lot of your work, your realizations, your innovations. We're so excited to see them. And so what we'll do is we'll start with the presentations of our most honorable people that we have here. First, we have the Brilliant Labs CEO, Mr. Jeff Willson. Est-ce que you want to come and do the presentation? Or, yeah, we're starting, yeah.
Bonjour tout le monde. Hello, everybody. I think half of us are still in the lobby, but we'll get started anyway. So, bienvenue tout le monde, the second annual Brilliant Blue National Challenge that leads to the international or global challenge that happens here in the fall. Alors, merci à vous de venir. Je sais qu'il y en a qui se sont déplacés de très loin. On a aussi, je pense, une équipe du Bas-Saint-Laurent au Québec. Est-ce que vous êtes ici? C'est ça? Is there a team from Quebec here? Une équipe du Québec? Non? Edmundston? Oh, vous êtes en arrière là-bas. OK, il faut faire du bruit un peu. Alors, bienvenue. Je pense qu'on a des équipes peut-être de l'Ontario. Maybe some Ontario teams. Awesome. Any New Brunswick teams? They're not as excited. Do we have any Newfoundland Labrador teams here with us? Ah, there you go. So yeah, we've got quite a few Nova Scotian teams, New Brunswick teams, Ontario teams, and also some teams joining us virtually online once we get the feed up and going. Alors, en tout cas, un gros merci. Avant qu'on commence trop, je pense que j'aimerais faire une reconnaissance du territoire. Alors, donnez-moi 2 secondes, s'il vous plaît. OK. Alors, les labos créatifs reconnaissent que les terres sur lesquelles nous offrons nos programmes se trouvent sur les territoires non cédés et traditionnels des premiers peuples. À Terre-Neuve et Labrador, notre organisation se trouve sur les terres des Inuits de Nunavut et du Nunatu-Kavut, des Inuits de Nitissina, des Beothuk et des Mi'kmaq. À l'île du Prince-Édouard et en Nouvelle-Écosse, nous retrouvons nos amis et collègues situés sur le territoire des Mi'kmaq. Au Nouveau-Brunswick, nous nous trouvons sur les terres des peuples Wolastoqey, Mi'kmaq et Passamaquoddy. Ces territoires sont reconnus dans une série de traités de paix et d'amitié visant à établir une relation permanente de paix, d'amitié et de respect mutuel entre les nations égales. Alors, les organismes labos créatifs souhaitent exprimer sa sincère gratitude au peuple Wolastoqey, Mi'kmaq et Passamaquoddy qui partagent avec nous leur terre ancestrale. Brilliant Labs respectfully acknowledges that the lands on which we offer our programming are on the unceded and traditional territories of First Peoples. In Newfoundland and Labrador, our organization sits on the homelands of the Inuit of Nunavut and Nunatu-Kavut. Thank you for bearing with me in my pronunciations. The Innu of Nitisinan and the Beothuk and the Mi'kmaq peoples. In Prince Edward Island in Nova Scotia, we find our friends and colleagues situated in the territory of the Mi'kmaq. In New Brunswick, we are found on the land of the Wolastoqey, Mi'kmaq, and Passamaquoddy peoples. The land of Wabanaki people are recognized in a series of peace and friendship treaties to establish an ongoing relationship of peace, friendship, and mutual respect between equal nations. Brilliant Labs wishes to express sincere gratitude to the First Peoples who share this ancestral homelands with us. And also with that comes a duty to preserve our waterways and be respectful of all things in nature. And so, que ce soit des rivières, des lacs, des fleuves, des baies, des océans, so whether it be oceans, bays, and here, close to home, we've got the Bay of Fundy with the highest tides in the world, where we need to do a better job generating renewable marine energy. So hopefully maybe some bright minds like you will come up with a brilliant idea and help us figure some of that stuff out. Alors, ce que vous faites aujourd'hui, on va avoir des présentations publiques ici sur l'estrade. Vous allez avoir aussi la chance de présenter aux juges. Stressez-vous pas. c'est la première étape. Chez en Ontario, j'ai dit la même chose. OK, pour vous autres en Ontario, c'est la deuxième étape. Mais vraiment, c'est une conversation qu'on veut avoir comme groupe ensemble. Alors, vous avez tous répondu au défi. Vous êtes tous ici. Vous avez tous eu du succès. So you've all answered the challenge. You're all here to have a conversation about how to solve these important problems. And so without your brilliant young minds, we can't do it without you, because our ancestors have tried, my generation is trying, we're not doing so well. We need your help. So keep being creative, keep being brilliant. L'autre chose aussi que j'aimerais mentionner, c'est que le plus de chances que vous avez aujourd'hui à interagir avec d'autres groupes, d'autres équipes de d'autres provinces, il y a peut-être une équipe qui a peut-être des idées pour vous autres. Alors, c'est le réseautage qui serait aussi très important. Alors, n'oubliez pas de communiquer le plus que possible. Puis, je sais qu'il y en a qui sont un peu nerveux. L'estrade, c'est une grosse estrade. Mais inquiétez-vous pas, ça fait partie de votre encadrement, votre parcours. Alors, right? So, some of you are maybe a little nervous about coming on stage today to present. Don't worry about it. It's fun. Enjoy it. It's part of your kind of, learning journey. Just, what do they say? Well, I'm not going to say it. But essentially, difficult things help make us better people, right? Alors, sans plus tarder, je pense que je vais redonner la parole à Patrick. So, without further ado, I'll hand things back over to Patrick, and we can get our wonderful day started. Thank you, everybody.
Thank you, merci, Jeff. So now I would like to invite Ms. Kerri McPherson, who's a science consultant for Nova Scotia Department of Education and Early Childhood Development. J'aimerais inviter Mme Kerri McPherson, consultante scientifique au ministère de l'Éducation et du Développement de la petite enfance de la Nouvelle-Écosse, à venir partager un petit mot.
Hi, good morning, everyone. Can everyone hear me okay? I hope that I'm coming through. My name is Kerri McPherson. I am the science consultant with the Nova Scotia Department of Education and Early Childhood Development. In my role, I support the development of science curriculum from primary through to grade 12, and I have a particular interest in ocean and climate education. So it is an immense pleasure to welcome all students here to the National Brilliant Blue Challenge. Programs like the Brilliant Blue Challenge are incredibly important because they bring together youth, innovation, and real-world problem solving. This challenge provides an opportunity for students to think creatively, collaborate, and explore solutions to some of the most pressing issues in our oceans today. So it is really inspiring that all of you are here engaging with these challenges and imagining new possibilities for the future. My own academic background is in marine biology, and I understand how central the ocean is not only to Nova Scotia, but to Canada and the world. Today, Canada's ocean sector is rapidly evolving with growing opportunities in areas such as ocean technology, renewable energy, climate science, sustainable fisheries, and marine conservation. These fields require innovative thinking, interdisciplinary collaboration, and new generation of leaders who are ready to approach challenges in creative and meaningful ways. So this is why initiatives like the Brilliant Blue Challenge are so important. They extend this learning beyond the classroom and help students like yourselves develop the skills, knowledge, and confidence needed to engage with complex environmental issues. And more importantly, they highlight the wide range of pathways and careers available in the ocean sector, so many of which are still emerging and will continue to evolve in the years ahead. So as you participate in today's challenge, I encourage you to embrace the opportunity to think boldly, collaborate with others, and explore new ideas. This is an exciting time to be involved in ocean innovation, and the work you're doing here has the potential to contribute to a more sustainable and resilient future. I hope your experience today is engaging, inspiring, and full of possibility. So have fun, and thank you.
Thank you, Madam McPherson. Thank you, Ms. McPherson. We also have the pleasure of having a message sent to us by the Honourable Lena Metlege Diab. Sorry about the pronunciation there. She's a member of Parliament for Halifax West and the Minister of Immigration, Refugees and Citizenship. Nous avons maintenant aussi un message de l'Honorable Lena Metlege Diab, qui est députée de Halifax West et ministre de l'Immigration, des Réfugiés et de la Citoyenneté. Ce message sera lu par Grace. Grace.
Okay, so Miss Lena Metlege Diab says, greetings everyone, bienvenue. I am pleased to extend my warmest congratulations to all participants at the Brilliant Blue National Competition. It is inspiring to see young Canadians from Halifax and across the country stepping forward to explore opportunities in STEM and to develop innovative solutions to protect our oceans. Canada is home to one of the longest shorelines in the world, and the future of our ocean economy and marine ecosystems will depend on creativity, dedication, and leadership of young people like you. I would also like to recognize and thank the organizers, mentors, and volunteers who have made this remarkable initiative possible. Your commitment to fostering curiosity, innovation, and environmental stewardship is helping to shape the next generation of leaders in marine science and technology. I wish all competitors the very best as they present their ideas and continue to make meaningful contributions to the future of our oceans. Bonne chance à toutes les équipes. Sincerely, the Honourable Lena Metlege Diab.
Thank you, Grace. And now I would like to invite Mr. Dave Corkum, mayor of the County of Kings. Monsieur Dave Corkum, le maire du comté de Kings, à venir partager quelques instants to share a message.
Good morning. I'm Mayor Dave Corkum, and it's my pleasure to say a few words on behalf of the municipality, council, and staff of the County of Kings. I hope you'll excuse my bias here this morning, but I am a politician, so don't forget. I'm pleased to share that the hardworking team of students from West Kings District High School in Auburn qualified to compete in this national competition. Congratulations to Dominic Radley and Creeshaw Lee, and a special thanks to their advisors, Logan Dye Adams and Ellis Brian Clayton. It's very exciting to know that Kings County is well represented here on the national stage. I'd also like to congratulate our fellow Nova Scotians competing today and welcome our guests visiting from elsewhere in Canada. I wish you all success in the competition, and most of all, I hope you enjoy connecting with like-minded peers and taking in all the event has to offer. I was fortunate to participate in a national sporting event once in my lifetime, and I still hold the fond memories from that experience near and dear to my heart. These opportunities are rare, and I hope that you're proud to be here. I want to thank you for inviting me to say a few words at the opening ceremony. It is refreshing to be part of an event that celebrates the intelligence, creativity, drive, and passion of our leaders of tomorrow. It is encouraging to know that junior, middle, and senior high school students are already thinking about protecting the environment and the health of oceans. I hope you find inspiration in the ideas shared by your peers and continue to see yourselves as part of the solution long after you leave here today. Congratulations to all the competitors, their mentors, and their greatest supporters, and all those that have put this event together. All the best. Thank you very much.
Thank you, Mayor Corkum. We now have a message from the Mayor of Halifax, Mr. Andy Fillmore, who could not be with us today. So his message will be read by Grace again. On a un message du maire Andy Fillmore de la ville de Halifax, qui ne peut pas être présent ici aujourd'hui, mais son message sera lu par Grace.
following is the message from Mayor Fillmore. As Mayor of Halifax Regional Municipality, and on behalf of the Regional Council, I extend my sincere congratulations to all students participating in the 2026 Brilliant Blue National Competition. Reaching this national stage is a significant accomplishment and reflects months of hard work, creativity, and collaboration. Through this competition, you are developing ideas and skills that will help shape the future of marine science and sustainability. We are proud that Halifax is hosting this year's national competition at Dalhousie University, and especially proud to see students from our community represented among the competing teams. Congratulations to the students from Halifax Grammar School, Halifax West High School, Citadel High School, and the Halifax Regional Center for Education on earning their place at this event through dedication, innovation, and perseverance. I commend all students, mentors, and educators involved, and thank Brilliant Labs, Dalhousie University's Office of Sustainability, and partners for providing this important national platform. I wish every team continued success as you share your ideas, celebrate your accomplishments, and look forward to the future you are helping to shape. Sincerely, Mayor Andy Fillmore.
Thank you, Grace. Okay, and now we have a message from Ms. Stephanie MacPhee.
Hello, everyone.
The Executive Director of the Office of Sustainability of Dalhousie University. Nous avons un message de Stephanie MacPhee, qui est directrice exécutive du Bureau de la durabilité de l'Université Dalhousie.
Hello, everyone. I'm so sorry I couldn't be there with you in person, but I did want to send in this message. I'm Stephanie MacPhee, and I'm the Executive Director of Dalhousie's Office of Sustainability. We are so proud to support the Global Brilliant Blue Challenge, especially after hosting the National Challenge here at Dal in June. We recognize how critical youth are in building a sustainable future. And at Dal, we're committed to supporting youth just like you who are already leading that change. It's truly so inspiring to see so many bright, passionate youth and educators in one space, all excited about growing the blue economy. I first want to acknowledge that Dalhousie's Halifax and Truro campuses are located in Mi'kmaq, the ancestral and unceded territory of the Mi'kmaq people, and we are all treaty people. The Mi'kmaq Nation holds inherent rights as the original peoples of this land, and we each carry obligations under the treaties of peace and friendship, not just to uphold them, but to go beyond reconciliation towards true decolonization. That path will look different for everyone, but I just want to encourage you to reflect on how your ideas, solutions, and projects can support that journey. It's also important to recognize that African Nova Scotians are a distinct people whose legacies and contributions have enriched Dalhousie and Mi'kmaq for more than 400 years. So maybe you're thinking, how exactly does sustainability align with the ocean sector? Well, the blue economy refers to sustainable use of ocean resources for economic growth, improved livelihoods, and job creation, all while preserving the health of our ocean ecosystems. It includes a wide range of ocean and coastal-related industries. While it's often used as a buzzword, it ultimately represents a global push for sustainable development in the ocean sector. Sustainable development means meeting the needs of the present without compromising the ability of future generations like you to meet your needs. It's grounded in 3 pillars of sustainability: economic sustainability, social sustainability, and environmental sustainability. The challenge's alignment with sustainable development in the ocean sector, alongside its strong focus on engagement and innovation, is a key reason why the Office of Sustainability is so keen to support Brilliant Blue Labs. We firmly believe that through meaningful collaboration and engagement, grounded in strong research, we can co-create innovative solutions that are both effective and sustainable for the long term. Programs like the Brilliant Blue Challenge give students like you a chance to explore the possibilities of the ocean sector early on. And if you enjoy the challenge, consider furthering your post-secondary education here at Dal. We are leaders in sustainability, ocean science, engineering, and so much more. Just visit our website to learn more. Thank you so much, and good luck with your challenge.
Thank you, merci, Madame MacPhee. And now I would like to invite Mr. Léo Dignard to share a few words. Il est le conseiller pédagogique en STEM, Educational Consultant STEM Learning, pour les écoles le Conseil des écoles publiques de l'Est de l'Ontario. for the Eastern Council of Schools of Ontario.
Merci beaucoup. J'essaie juste de partager ma présentation. Moi, une seconde. Je ne sais pas si quelqu'un de votre côté peut essayer de le partager. J'essaie de partager juste mon écran. Une seconde. Si je clique sur le plus ici, charger. Tantôt qu'on a fait le test, ça fonctionne. OK, désolé, je l'ai. C'est bon. Donc, merci beaucoup. Comme on l'a mentionné, je suis conseiller pédagogique au CEPEO, chargé du projet de la compétition régionale du défi bleu brillant franco-ontarien qu'on a organisé la semaine dernière à Ottawa, les 9 et 10 avril. Donc, je voulais juste vous donner un petit peu un coup d'œil de cette première compétition qu'on a organisée en partenariat avec Bleu Brillant. Donc, c'est ça, je vais pas besoin de me présenter plus longuement, mais je voulais souligner quand même que j'ai une collègue qui n'est pas ici, qui est Julie Campeau, qui a été co-responsable du projet avec moi. Quand même un projet d'envergure qui ça fait plus de 12 mois sur lequel on travaillait. Donc, qui s'est culminé par l'événement la semaine dernière. Donc, voici un petit survol rapide, comme si vous y étiez, de cet événement qu'on a eu la semaine dernière. Donc, quelques informations. C'était une compétition régionale franco-ontarienne organisée par nous, le CEPEO, qui est le Conseil des écoles publiques de l'Est de l'Ontario, en partenariat avec Bleu Brillant et Labo Créatif. Au nom du CEPEO, je désire d'ailleurs remercier énormément Omar Hussein de Bleu Brillant et Jeff Willson de Labo Créatif pour leur collaboration dans ce partenariat fructueux pour organiser cet événement. Donc, pour nous au CEPEO, on est très heureux de s'associer avec Bleu Brillant puisque ça s'inscrit dans notre promotion des STEM ou les SIAM, comme on les appelle au CEPEO, également dans une initiative de développement durable au CEPEO. Donc, notre événement, comme on l'a dit, a eu lieu jeudi le 9 avril et vendredi le 10 avril dans l'espace Innova qui se trouve, ceux qui ne sont pas familiers, sur le campus de l'Université d'Ottawa. Au total, on a eu 71 élèves qui ont participé de la 7e à la 11e année. On a 21 équipes provenant de 5 écoles différentes. On salue d'ailleurs nos représentants de cette compétition qui nous représentent à la compétition nationale, qui sont les membres de l'école secondaire publique Maurice-Lapointe et l'école secondaire publique L'Héritage, qui sont présents sur place. Je salue aussi ma collègue Sandra Sauvé qui accompagne le groupe lors de la compétition nationale. Donc, outre les présentations des équipes, on a aussi eu plusieurs ateliers qui ont eu lieu en lien avec l'économie bleue et les domaines connexes au STEM. Donc, je vous en fais part très rapidement. On a eu, par exemple, une présentation de l'équipe Kelpie Robotics, qui est une équipe d'ingénierie de l'Université d'Ottawa qui nous a partagé leur prototypage au niveau de robots submersibles qui aident notamment à éliminer les microplastiques dans la rivière des Outaouais. Donc, ce fut fort intéressant d'avoir leur témoignage pour montrer à nos élèves également qu'il y a un futur dans les STEM pour eux au post-secondaire s'ils le désirent. On a également eu un atelier animé justement par Jeff Willson de Labo Créatif au niveau du codage avec des b-boards. On a eu aussi Maker Mobile qui ont utilisé des kits d'action climatique également pour engager les élèves à résoudre des problèmes en lien avec le climat et les océans. On a eu des ateliers de parlons sciences au niveau de la biologie marine. On a également parlé des objectifs de développement durable. Les élèves ont eu à classer notamment les objectifs de développement durable en termes de priorité pour eux. Donc, ça, c'est une des petites activités qui a été proposée. On a également eu Ottawa River Keepers ou Garde-Rivière des Outaouais, qui est un partenaire local qui est venu parler aux élèves des bassins versants. On a fait une simulation avec une maquette et les élèves ont également eu la chance de faire une mini-activité d'analyse d'échantillons d'eau. On a eu également un partenariat avec le Musée canadien de la nature qui a offert aux élèves un atelier virtuel qui nous a transportés au musée dans l'exposition de l'écosystème de l'Arctique. Ceux qui ne sont jamais allés au Musée canadien de la nature, c'est au 6e étage. Si jamais vous êtes en visite à Ottawa, on vous recommande grandement d'y aller. Et on a également eu une présentation, une mini-conférence du professeur Jon Nestor, qui est un professeur en ingénierie, qui étudie plus spécifiquement les tsunamis et les effets des tsunamis sur les côtes. On a eu la chance d'avoir son expertise pour nous parler de comment on peut sauver des vies au niveau de l'architecture afin de faire en sorte qu'elles sont résistantes aux tsunamis. On a également eu la chance de visiter, vous voyez dans la photo à gauche, le seul simulateur de tsunami en Amérique du Nord qui permet de produire une simulation de vagues qui a vraiment impressionné tout le monde, autant les adultes que les élèves. Donc, c'était fort intéressant cette visite. On a également terminé notre vendredi avec un petit panel sur les STEM. Donc, on avait plusieurs gens que vous voyez, notamment un expert du musée de la nature au niveau des invertébrés, une étudiante en génie civil, d'autres étudiants en géologie marine, un membre de l'équipe Kelpie Robotics, une étudiante en sciences environnementales et une représentante du River Institute à Cornwall qui étudie le Saint-Laurent. Donc, on leur a posé plusieurs questions en lien avec les STEM. Le but était vraiment de faire découvrir aux élèves différentes carrières connexes à l'économie bleue et les STEM. Donc, ce fut fort intéressant d'avoir leur participation et également les questions des élèves. Donc, je vais terminer mon allocution ce matin en soulignant justement nos équipes gagnantes qui nous représentent au national. On leur souhaite bon succès. On ne va pas leur dire bonne chance parce que je ne pense pas qu'ils ont besoin de chance. On va leur dire bon succès aux équipes suivantes. Donc, l'équipe en véhicule marin autonome, on a Mason Kruber, Aitiam El Moujahid, Abdou Metlege Arsène Palco et Jackson Richard Arts. On salue également leur mentor et accompagnant, Rabat Farez. On a également notre équipe dans la catégorie énergie marine renouvelable, soit Angelica Carrizina, Ethan Shore, Lena Amouden, Quinn Lamley, Sarah Ojej et également, comme je l'ai mentionné, M. Rabat Farez. Et on a également notre équipe de l'école secondaire publique L'Héritage dans la catégorie vie marine saine, soit Stéphanie Cruzel, Ryan Dohan, Taylor Dohan et Firaz Louafi, et leur enseignant Larbi Naït Chabad. Donc, on en profite pour leur souhaiter le meilleur des succès lors de cette journée de compétition aujourd'hui. Et on termine en remerciant tous nos partenaires, en particulier Bleu Brillant, évidemment, pour l'occasion d'organiser cette compétition régionale. On espère refaire le coup l'an prochain. Et on veut aussi souligner les généreuses contributions en temps, en ressources et en argent de M. Jeff Willson de Labo Créatif, qui était instrumental pour permettre à nos élèves d'assister à la compétition nationale aujourd'hui et demain. Donc, je vais terminer là-dessus et je souhaite aussi bon succès à toutes les équipes qui participent. Continuez d'innover et puis j'espère que vous allez avoir une très belle journée de compétition.
Merci, M. Dignard. Thank you, Mr. Dignard. J'inviterai maintenant M. Kent Smedbol, Senior Director, Science Program, directeur principal des programmes des scientifiques, DFO, UN Ocean Decade Champion and Judges Advisor, MPO, champion de la Disney des océans de l'ONU et conseiller des juges, à partager le message.
Thanks all, and just Kent is fine, not that long title. So I'm going to try to be quick because I know we're a little pressed for time. So I'm going to talk a little bit just about why I'm here, why I'm a big supporter of Brilliant Blue, and then if I may take a couple minutes and speak directly to the teams and about your experiences with your projects. So as with the introduction, I'm Ken Smedbol. I work for Fisheries and Oceans Canada in the Ecosystems and Ocean Science sector. One thing I want to highlight about science in the public sphere. So at DFO, I work across the harbor actually at the Bedford Institute of Oceanography. That's one of many facilities across the country. DFO Science comprises over 2,000 scientific employees. So that's scientists, biologists, oceanographers, engineers. So I'm going to put in a little bit of a plug. If you are interested in doing science, but science for the public good, that's what we do. We work in service for Canadians and for coastal communities. All our research and our monitoring focuses towards the benefit of Canadians. So if you'd like to look forward to a career in oceanography or science or ocean technology and you want to serve the public, give us a little thought before moving on to the private sector. Anyways, the main reason why I'm here, though, is because I am a big supporter of this event, particularly through my role with the Ocean Decade. So I am lucky enough to be one of Canada's official Ocean Decade champions, and this event is part of the Ocean Decade process itself. This is an endorsed event internationally for the Ocean Decade. And a little bit about the Ocean Decade, I'm not going to get too much into that. We're halfway through the decade, and I think most of you have heard about it. But the main vision statement for the Ocean Decade is the science we need for the ocean we want. And the mission is transformative ocean science solutions for sustainable development, connecting people in our ocean. That's a bit of a mouthful, but the main thing is that it's forward-looking. It's long-term, it has a generational focus, and that means its outputs are for you and not for me. We're looking forward, and the work that we do now and we like to support is to ensure sustainability into the future. Now, I think, and I said I'm going to cut this a little short. I'd like to speak a little bit to the teams, if I may, based on some conversations I had last year at this event with some of the teams after it was over. And I found them really informative and quite heartwarming. But some of the discussion was talking to teams. They said, well, we had this project and we tried this and it didn't work. Or we had this idea and we pushed it forward a little bit and, it failed. Well, ocean technology, technological innovation in the scientific method is based on failure. That's baked into the process. In fact, we as practitioners don't think of that as failure. That is part of how we learn. So, when you first ask a question, of how to do an experiment, you don't know the answer. So you design it in such a way as to, could this system work this way? You do a study and it says, no, okay, but you've learned from that. That's part of the process. When you're building a prototype for some sort of technological tool or a vehicle or anything like that, you start in the same way. You're not really sure how it works because you're trying something new. But each time you fail, and that's not a bad word in technological development or science, but each time you fail, you learn from that. So what I would say to the teams is that I'm sure all of you have reached or have had some of those, call them small setbacks, but each one of those actually improves your ability to focus on the pathways that may be more informative because you don't know in advance, right? So embrace your failures. That's part of the process. And certainly those of us who do this for a living, we're very comfortable with it because it happens to us all the time. So those are not negatives. That's part of how we learn and part of how we develop new things. So with that, I would say embrace your failures, team, and enjoy today's event. And same thing, if something doesn't quite work the way you want it during your presentation, that's normal. So don't get too freaked out about it, okay? Enjoy today. Thank you very much.
Thank you, Sir Smedbol. Merci, Monsieur Smedbol. Et maintenant, j'inviterai le directeur de Blue Brilliant, the director of Brilliant Blue, who made this event possible, Mr. Omar Hussein. Mr. Omar Hussein.
I'll try to be quick. Bonjour à tous. Good morning, everyone. Welcome to our second National Brilliant Blue Challenge. It's incredible to see how much this community has grown in 1 year. The number of teams has doubled. We have teams from 5 provinces, and we had our first provincial competition earlier this month. You're here because you refused to accept the status quo for the ocean. You've spent weeks and months researching, prototyping, and collaborating to turn what if into what's next. Whether you're returning or joining for us for the first time, you're not just competing for a spot for the global competition in October. We're expecting around 40 countries to join us in October. You're already contributing to the global blue economy. A sincere thank you for our funders at the Nova Scotia Department of Education and Early Childhood Development, our partners at Dalhousie University's Office of Sustainability, and EY, Ernst & Young, and our Ontario provincial partners, Conseil des écoles publiques de l'Est de l'Ontario. Special thanks to the advisors and parents who supported the students. We really appreciate your support, and to all our volunteers and staff. To the students, the world needs your ingenuity now more than ever. Aim high, support one another, and most importantly, have fun. I'm honored to officially open the competition. Let's dive in.
Thank you, Mr. Hussein. Merci, Mr. Hussein. All right, so here we are. Are you ready? I said, are you ready? No. J'ai dit, êtes-vous prêts? Good. Well, we'll start in about 10 minutes. So go to your tables, network, mend your minds. Talk to other teams, get ideas. Allez voir des équipes. Mélangez vos esprits. Pognez des idées. It's going to be awesome. Okay, Marc-André, are you with us?
Oui, je suis avec vous.
Okay, can we see you on the screen? Is that working? I'm not sure.
That's going to be a Neil. Ça va être à Neil et à Brandon à vérifier ça, je crois. Mais en attendant, je peux continuer à être un ange.
OK. So, on va commencer dans 2 minutes. Là, on va avoir la première équipe qui va se présenter qui s'appelle Duct Innovators. They're going to start in about 2 minutes. So, would you like to share something with us about a fact of the ocean, Marc-André, or something like that?
Sure. Petite question petite question pour vous. A little question for you. How much of the Earth is covered by ocean? Quel pourcentage de la Terre, finalement, sera recouvert par des océans? Poserai la question, I'm just asking.
Okay, and I'm looking, I have raised hands here. Je regarde des mains levées. Does anyone know the answer? Anyone knows the answer? Quelqu'un connaît la réponse à la question? Okay, Marc-André. Oh, we got an answer over there. You'll have to shout it out because you're far. Il dit 71%. Is that right?
Bon. Yes, exactly.
Good job. Wow, good, awesome. All right, so we're just about a minute away from the first presentation. So we'd like to take a moment and just, oh, there you are. Hey, how are you, buddy? Look at you all
Good.
sharp and stuff.
Moi, je peux pas te voir, par exemple. I can't see you, but I can hear you loud and clear.
Okay, parfait. Well, you're not missing a whole lot, I can tell you that. Self-deprecation. Okay, so it is 10 o'clock, so we're going to start with our first presentation. Duct Tape Innovators, I'll invite them to the stage so they can share their project and talk about their innovation. of the Marine Autonomous Systems. Duct Tape Innovators.
Hello, everyone. Thank you all for being here today. And this is Berwick Dynamics.
So our team members are Dominic Radley. He's our president. I'm Krishan Lee. I'm the CEO, and we have Logan D. Adams, which is our COO, and Ellis Brian Clayton, which is our VP of Marketing.
So a little about us. At Berwick Dynamics, we're a two-person development team. We're trying to bring back an open source market for an underwater ROV project. And slightly after we started innovating on this, we started our company, Berwick Dynamics.
Our business models is research. We base our research on what users wanted to see in open source ROV projects, development. We believe in making our products are tested and confirmed to be working before we are putting them on the market. In design, we wanted to make our products an easy to use as possible, letting us be an acceptable option.
So here's the problem with today's market. Professional ROV devices or remotely operated vehicles, they cost tens of thousands of dollars on the entry-level market. And it leaves it so not many people actually are able to buy one to do their own research. Another major problem is many companies who develop these devices aren't actually helping very well with support when issues arise. And another thing we wanted to focus on is we wanted to make sure our project's open source. This lets everyone who uses our product develop it for how they want to do it, so they can use their own software on our devices.
Our solution, we want to close the gap, reintroduce the ROV device to homes, markets for modest price, find target audiences. Our target audience is anyone who has more experience with technology and coding. Our cost savings using open source hardware that can be bought for everyone helps us save on resources, and easy to use. Our users who don't feel like tinkering with tech and stuff like that can use our ROVs safe. It's ready to use and stuff.
So this is our company's growth strategy. By February 2027, we want to start supplying reviewers with units. This way we can get some crucial feedback on any issues. By May 2027, that gives us a month between then to hear any user feedback, see what they do and don't like, and actually refine our issues to make a better product. And finally, by June 2029, we want to take all the feedback we can get, because this is after our device will be on the market for everyone. We want to see what people want changed to try and make a smaller footprint on our devices, but keep our core business model.
So this is our 2-year business plan. So in February 2027, we want to supply our ROVs to reviewers. And then by May 2027, we want to get the reviews back and change our products to make everything better for our users. And then October of 2027, we want to launch a remote app for iOS and Android. And of December 2027, we want to launch our pre-orders. And then February of 2028, we want to begin shipping our pre-orders out to customers. And then July 2028, we want to open our SDK platform. And then by December of 2028, we want to have a platform for our users to be able to communicate to each other about our products.
Just to reiterate on a SDK platform, just for people who may not be aware, SDK is our software development kit. This lets anyone develop for our devices. So, our product overview. We are trying to be unique. We're currently the only people developing an open source ROV project, and we're going to be first to market with that. Our open source project is the first modern solution on the market. And our product's going to be tested before it ships out to the public. We want to make sure everything's refined for the best user experience. And with the help of others in the field, it really brings together our product.
So this is our product, what you've been waiting to see.
This is the Berwick Dynamics Scout. It is our ROV device. This is still in the prototype phase, I'd like to add, just so everyone knows. It will be different upon release. However, this is a current working model. This will go in water and do its job as it is currently.
So our features, we have an HD camera on the front so you can see when it's in the water. We have an adjustable weight, so you can like put different weights in that tube. It has like an opening. And we have a quick adapter for the power when you're ready to plug it in.
So the reason we have an adjustable mass is different water, different salt content. You need to be able to change how it's neutrally buoyant, so it'd be different amounts of weight. So that's why we wanted to have it there, just so it can be changed to be neutral. And the quick connector for power, so there's different power options. Currently we have a battery on land, but we like to have an XT30 connector on there, which is industry standard. This lets us have different power options, potentially ones that can go in the water to save on weight. So to reiterate on our benefits, it's simple and efficient to use. Our quick customer service is there to help anyone who does have issues that may arise. And for every order, they're getting a 90-day free trial of our cloud storage for any videos or photos.
So we're going to show you how it works.
I'm not going to go over all of this. It's quite confusing. This is already dumbed down. But to make it simple, all the electronics are off of readily available microcontrollers. These are all linked together and going into a laptop or any device that runs an operating system that has an x86-based processor. And having this all be hardware that's readily available does keep our costs low. So I just wanted to say thank you, everyone, for being here today once again and giving us a chance to present our product. Thank you all.
Thank you, Duct Tape Innovators. Any questions for Duct Tape Innovators? They left quickly, but I do have a question for Duct Tape Innovators. Where is the duct tape?
So in our prototypes, we did use duct tape. However, we thought for today that we'd want to make it look closer to what we'd aim to ship to consumers.
Okay.
So we changed it from duct tape.
Okay. Marc-André, did you see the presentation?
I was actually watching through YouTube because I can't see really what's going on, but I heard a lot, and I'm actually right now I'm seeing you on the podium, and you look kind of snazzy. You're kind of cool. Vraiment, t'es beau. C'est quoi? I could just imagine your coat made out of duct tape. That would be kind of cool.
Oh, all right. Okay. Well, thank you, Duct Tape Innovators. Where's your station? It's over there, right? So if you guys want to see the prototype, I saw it's over there too. So go have a check them out. So the next team that will be presenting is Sirens. So we'll let them give them time to install themselves, set themselves on stage, and while we wait, I do have a trivia question for you guys. So, what is the average salinity of seawater? Quel est le niveau de sel de l'eau de la mer? Anyone? Anyone? Bueller? 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 Ah, j'ai entendu 3%. Is that right? Oh, it's close. Any better guesses? Any better guesses? It's 3.5%. So there you go.
Is that more than what I have in my salt shaker?
I think so, yeah. Toi, tu vas le puiser directement dans la rivière, right?
Oh, c'est ça.
Yeah. Okay, so is Sea Siren ready to be presenting, or are you guys still setting up? You're good? Oh, you're still setting up a little bit? Okay, we'll just wait. No problem. So while we wait for that, Marc-André, ready for a dad joke?
Always ready. Moi, les dad jokes, c'est la meilleure chose au monde.
Okay, so why don't fish play basketball? Because they're afraid of the net. Oh, but don't fish. All right. Okay, so Sea Siren are ready. All right, Sea Sirens, everybody.
One, two, three. Oh, this one works too. Yeah. Wait, somebody hold it. You want to change the slides? Actually, I got it. Okay. Actually, no, I don't got it. I can. Okay. All right. Good morning, and thank you for being here today. We are Team Sea Sirens. Imagine an organism that silently spreads across our coastlines, attaching itself to infrastructures, disrupting marine ecosystems, and costing industries thousands in damages each year. Now imagine if that same organism could become the foundation of an entirely new sustainable industry. SPG 3000 is a surface control underwater harvesting system designed not to only address the growing issue of invasive tunicates in Atlantic Canada, but to completely redefine how we respond to it. Today, we'll walk you through the problem, our approach, and how the SPG 3000 has the potential to reshape both marine management and our blue economy.
Okay, now a quick question for the audience. What do you think is the main reason mussel farming has declined in Nova Scotia? Well, spoiler alert, it's actually sea squirts. We found this out after talking to industry expert Mr. Peter Dannell and spending time with Mr. Ken Diab. The ocean works like a system with ecosystems that keep the planet in balance. The upset of this balance oftentimes encourages the spread of invasive species. Warmer waters with no natural predators saw their population soar out of control. The combination of these factors has decimated the mussel industry in Nova Scotia, facing up to 90% in losses in places like Lunenburg Bay. Now, Canada has a lot of invasive species, and just like our predecessors from Halifax West as previous teams, we aim to curtail and minimize the effects of these invasive species by creating smarter, more efficient ways of containment, elimination, tracking, and use. Sea Sirens as a group, though, aims to focus mainly on tunicates due to their adverse effect on the local blue economy.
So what is the issue? Sea squirts are small, invasive marine invertebrates that were first observed in Nova Scotia waters in 2012. While they may seem harmless, sea squirts are very effective at colonizing hard, submerged surfaces such as rocks, boat hulls, and aquaculture equipment. The species we are focusing on is the European sea squirt, which have a leathery outer tunic and their organs inside. These components of the sea squirt are what we are interested in. The European sea squirt is a non-native, particularly invasive species in Nova Scotia. They are fast-spreading tunicates, and along with the changing climate, they have been able to spread uncontrollably. Since they have arrived in Nova Scotian waters, these sea squirts essentially destroyed the mussel farming industry. Shellfish industries have tried methods to manage the sea squirt population, but have been unsuccessful. They affect everyone. Sea squirts are very good at colonizing, which can lead them to outcompete their other native species, like the mussels, for space and food, reducing the biodiversity. They also have significant impact on mussel farms and other aquaculture industries, as without regular cleaning of lines or nets, the sea squirts make growing and harvesting shellfish very difficult and unprofitable, which has had negative economic effects for communities that rely on those marine industries. So sea squirts affect you, us, and the sea. This species is native to Europe, but in the last few decades, it has spread around the world through shipping and climate change. As these species establish themselves in non-native habitats, they can be very difficult to eradicate, making management techniques critical for maintaining healthy ecosystems and minimizing the effects on the blue economy activities.
Now that we know about the problem, what exactly is the solution? Before we go into our own solution, let's talk about the already existing ones. The already existing solution mainly comprises of basically power washing mussel lines. And if you know anything about mussel farming, you would also know that this comes at the detriment to the mussels themselves. It oftentimes ends up wasting resources as well as sometimes even killing the mussels themselves. So what is our solution? Let's meet the SBG 3000. Now, our solution is a more efficient way of dealing with sea squirts. With so many of them around, instead of just destroying them, our project aims to harvest and harness their inherent value in the production of super underwater adhesives, as well as helping cancer research and its existence as an amazing source of protein. We aim to stabilize the population growth and create a new industry that takes care of the problem while also creating new opportunities in the blue economy. Now, how exactly does the SB 2000 work? It works by cycling water through the auger, creating a seal, using brushes that pull sea squirts off surfaces that they have settled on. The auger then moves them, and their remains are collected in a mesh bag, and it houses several sensors to also help aid tracking and monitoring of the species. It has a surface supply power, so it has no battery, and the operator can remain on the surface, so it doesn't require scuba divers. And in future prototypes, we aim to make it less of its own thing and more of an ROV attachment, and future iterations can be attached to other vehicles as well. Now, what exactly makes the SBG 3000 unique? Now, the SBG 3000 is unique because it's more than just a solution to one problem. It's a multi-pronged approach to the blue economy. Its sensors, for example, help us learn key patterns to predict growth hotspots. The collected data can be used to further research, whether it's into cancer research or into the adhesives produced by these sea squirts. Then the tunicates itself can be used in animal feed due to its extremely high protein content. All this to say that the SBG 3000 is a solution that collects the tunicates, preventing further spread, all the while providing new avenues for the blue economy.
All right, the next thing that we'll be talking about is marketing and opportunities. Commercialization. The SBG 3000 has a strong commercial potential in the environmental and industrial sectors. Its main market is aquaculture and fisheries, where tunicates and biofouling lead to costly damage. The system helps clean infrastructures, protect yields, and reduce labor. When it comes to commercialization, we would begin by improving the prototype into a durable marine-grade system, followed by pilot partnership, biomass processing development, and outsourcing manufacturing to marine equipment companies that already supply the aquaculture industries. Future application. Looking ahead, the future application of the SBG 3000 extends far beyond invasive tunicate harvesting alone. The SBG 3000 can be adapted to remove other invasive marine species and to maintain aquaculture nets, ducts, moorings, and renewable energy system. Harvested biomass could be turned into biodegradable materials, biofuels, agricultural products, and help support a circular economy. For the future, we plan to add automation, sensors, and data analytics. Opportunities. The SPG 3000 creates value for organizations involved in marine management and coastal industry. Conservation groups can use it for invasive species control and habitat restoration, while government agencies can use its sensors for monitoring and marine management. In aquaculture and fisheries, it removes biofouling from equipment and improving productivity and reducing labor. Coastal municipalities can use it to maintain harbor and docks. It also has educational value by demonstrating how innovation can solve real-life problems. Timeline. So, we are a team of 4 very busy girls. The project often has us working overnight, staying in libraries till odd hours, but we persevere. These were 2 of our biggest challenges. First of all, there were snow days. While we really enjoyed them as students, the time that we had together, since we are all involved in extracurricular activities, was really precious to us. So the fact that there was a time limit made it kind of a challenge. And the next thing, our 3D printer decided to give up on us at some point. And that's where our name actually comes from. The SPG 3000, C squareds be gone, and 3000 because it felt like at least 3,000 times that this printer was just not cooperating. And behind me, we have a timeline, and I just wanted to mention that in the brainstorming phase, so the second phase, it was when we came up with multiple designs for the SPG 3000, and also we divided our project into me and Trailblazer, focusing on tech and the business side of things, and then we had Erica and Minjin, who focused on research and 3D printing.
Moving forward, these are the long-term vision and next steps we came up with. Our long-term plan is to develop a full industry centered around tunicates as raw materials for different products that can be used across multiple industries. We will continue improving the SPG 3000 system, which will include integrating ROV control, so operators can monitor and control harvesting from the surface without relying on separate systems, making the process more efficient. We also plan to advance processing and training systems. This involves developing better equipment and methods to clean and process tunicates, as well as providing training programs for operators. In addition, we aim to expand both markets and products. The tunic and inner biomass can be processed into forms like dried, powdered, or cooked materials depending on industry needs, opening up more market opportunities. Finally, we will develop strong transportation networks that expand globally. These networks will support fast collection and delivery from farms to processing facilities, creating a complete supply chain through partnerships. To move forward, we have identified several important next steps. First, we will secure a steady supply of tunicates by partnering with aquaculture companies. This will ensure we have a reliable and consistent source of materials for ongoing testing and development. Second, we will test different processing methods. We will experiment with both the tunic and the inner biomass to find the most efficient and scalable ways to turn raw tunicates into useful products. Third, we will identify useful applications. This means exploring practical ways to transform these materials into real products that can be used across different industries. Next, we will support market development using our research and results. We will build business opportunities, connecting with industry partners and expanding into new markets for tunicate-based products. Alongside this, we'll introduce training programs for SPG 3000 operators to ensure safe and effective use of the device. Finally, we will focus on data collection and availability. The SPG 3000 system will collect important environment data such as temperature, turbidity, water depth. Oh my God. Okay, don't worry. This data will help improve harvesting strategies and will also be available for research and further analysis.
Thank you.
Thank you so much.
Thank you, Sirens. All right. So if you guys have any questions for Sirens, I believe they're over there, right? That's where you guys are? In the corner over there? Yeah? Okay. All right. So, Marc-André, you there?
Yes, I am there.
Okay. So I believe we're going to have a new team presenting in a couple of moments. You want to introduce them?
Yes, so next team is a team JossQuinn from Nova Scotia. And they will be virtual, so I think they are right here with me. Can we hear you, JossQuinn?
Yes.
Awesome, perfect. So if you want to turn on your webcam and presentation, you can do the. You can try to
Probably put your dragon in the cage, though. We don't want to see your dragon.
Pardon?
Right there.
Right here?
Right?
Oh, yeah.
Square that one right there.
Okay. Can we start now?
Awesome. We can see you now.
Okay. This is our Shark Safe Breakaway Net by Jocelyn Riley and Quinn Solos.
We want to make a shark-safe breakaway fishing net
JossQuinn, just a second. We don't see you on our screen here at the event. We're just going to fix that, and I'll let you know when we're ready.
While you're doing that, you might be able to see on the right side we have a little timer. So the timer is going to be I'm going to put us on start as soon as you start, and you've got 10 minutes to do your presentation. So I'm not going to start it right away. We're going to wait for the in-person people to let us know if you're ready to go or not.
Yeah, we are working on that right now. As we are working on that right now, we're going to share another trivia. Let's see. Okay, the Great Barrier Reef, the world's largest coral reef system, is located off the coast of which country?
Actually, you know what? Last year, my family and I traveled the world, and we actually went just by about let's say probably something like 500 kilometers from there. So I know the answer.
Oh, cool. So that's a great thing to go around the world and see all these things. Oh, there we go. Okay, now we got you. Perfect. Okay, we're ready to go?
But we kind of want to know where it is, though.
Yeah, we do want to know where the core. Yes. So where is the Great Barrier Reef? Anyone have an answer? Oh, we got an answer here. Australia. Good job. 2 points for you. All right, perfect. Okay, so JossQuinn, we're ready.
Okay. This is our Shark Safe Breakaway Net, designed by Jocelyn Riley and Quinn Solos.
We want to make a shark-safe breakaway net fishing net to help protect sharks from getting caught and killed. Every year, over 80 million sharks die because of overfishing and illegal fishing. Our net would snap or break if a big animal like a shark gets stuck, so the shark can get free. This way, we can help save endangered sharks while still letting fishermen catch smaller fish safely.
This is our prototype. Oh. The science behind it. Our design is a fishing net that uses magnets as a safety release system. The goal is to catch large amounts of fish while preventing bigger animals like sharks from getting trapped. At the bottom of the net, magnets hold parts of the net closed. These magnets act like a temporary lock that can break apart if too much force is applied. This allows the net to stay secure for smaller fish, but open when a larger animal is caught. The science behind it The science behind this design is based on magnetic force and the concept of force. Magnets attach. Magnets attract each other and can hold together with a certain strength. However, if a force stronger than the magnet attraction pulls them apart, they will separate. This means the magnets can be chosen to hold a specific amount of weight. In our net, the magnetic force is strong enough to hold fish, but not strong enough to hold a much heavier animal like a shark. Another important concept is the relationship between force and weight. All objects have weight due to gravity, and heavier animals create more force than they are caught in the net. In addition, large animals like sharks move and struggle, which increases the force even more. Water resistance, drag, also adds extra pressure on the net. When all the forces combine, they can exceed in strength of the magnets, causing them to snap apart and release the animal. Calculations. To calculate the force needed to break the magnetic connection, we use the formula FmG, where force equals mass times gravity. For example, a shark with a mass of about 200 kg produces a force of approximately 1,960 N. In comparison, a smaller fish with a mass of 10 kg produces only about 98 N of force. By selecting magnets with a holding force of around 500 N, the magnets will close. I'm sorry about that, that was our school bell. The magnets will close for smaller fish, but will break open when a large animal like a shark applies a greater force. This ensures the net is effective while also allowing larger marine animals to escape safely. This is a table that we made. It shows you the things. The table shows force increases with the mass of different marine animals using the formula FmG. Smaller fish produce much less force compared to sharks. For example, a 10 kg fish produces only 98 N of force, while a 200 kg shark produces 1,960 N. By choosing magnetics with a holding force of about 500 N, the net will remain closed for smaller fish, but will open when a larger animal applies a greater force. This demonstrates how the design uses physics to selectively release large animals and reduce bycatch.
Our business idea is to create a shark-safe breakaway fishing net. This net is designed to catch while allowing larger animals like sharks to escape safely. At the bottom of the net, magnets are used to hold it closed. These magnets act like a temporary lock that stays together for smaller fish but breaks apart when large animals apply too much force. This allows the net to work effectively while also protecting marine life. A major problem in the fishing industry is bycatch, which is when fishing nets accidentally catch animals that are not meant to be caught, such as sharks, turtles, and dolphins. Every year, millions of sharks die because they become trapped in fishing nets and cannot escape. This is harmful to ocean ecosystems and can cause certain species to become endangered because of this. There is need for safer and more environmentally friendly fishing methods.
Our solution is the breakaway net system that uses magnets as a release mechanism when small or medium fish are caught. The magnets remain connected and the net stays closed. However, when a larger animal like a shark gets caught, the force it creates is greater than the strength of the magnets. This causes the magnets to separate, opening the net and allowing the animals to escape. This design reduces bycatch while still allowing fishermen to catch fish.
The target customers for our product would be commercial fishermen, fishing companies, environmental organizations, and governments. These groups would benefit from our net because it allows them to continue fishing while also following environmental guidelines and protecting marine life. To create the net, we would need materials such as nylon fishing netting, strong magnets, and clips or connectors. The estimated cost to make one net would be around $50 to $70. Our product is unique because it uses magnetic force as a safety feature instead of only relying on strong materials. It is designed to break open on purpose when needed, which makes it different from regular fishing nets. This makes our design both innovative and environmentally friendly.
Statistics. Over 80 million sharks are killed every year due to fishing and bycatch. Sharks are declined by about 70% globally since the 1970s because of overfishing. Around 40% of fish caught worldwide is bycatch, meaning it's not the intended catch. Many shark species take 10 to 15 years to mature, making it hard for their populations to recover. About 1 in 3 shark species is now threatened with extinction due to human activities.
In conclusion, our shark-safe breakaway net is a simple but effective solution to the problem of bycatch. By using basic science concepts like force and magnetism, we created a design that protects marine life while still supporting the fishing industry. Our product is potential to make fishing safer and more sustainable for the future. This project is not about a competition or a grade. It is about protecting marine life and raising awareness about overfishing and bycatch. Every year, millions of sharks are harmed or killed after getting caught in fishing accident. Many people see sharks as scary, but they are an important part of keeping the ocean healthy and balanced.
We wanted to create something that could make a difference, even in a small way. Our shark-safe breakaway net is designed to reduce harm and give sharks a chance to escape. This project is about showing that small ideas can help solve big problems, and that protecting the ocean matters. It is not about it is just about science. It's about making a positive impact on the world around us.
Thank you, Team JossQuinn. That was awesome.
Thank you, JossQuinn.
So, does anybody have any questions in the audience?
Any questions for JossQuinn? Yes, in the back. Okay, so to resume, basically is the net with all the magnets. Once the big fish goes through, if there were small fishes in there, do they all go away? Is that the question?
Yeah.
But
and then do they,
it will
does the,
go back and forth.
Does the net close back itself?
Pardon?
Does the net close by itself afterwards?
Yes, the magnets would just go back together.
Okay, okay.
I'm just thinking of the movie's Jaws. You know that movie with that big shark there. I'm just wondering how big of of magnets would you need to be able to stop that big jaw, that big shark? It would be probably something super big.
Then again, Marc-André, do you think sharks are doing the same thing to save humans? I don't think so. So, thank you so much, JossQuinn. All right, so I invite Coral Nurseries now to come to the stage, or they're virtual as well. Oh, they're there? Okay, perfect.
My name is God's Favor. My name is God's Favor.
My name's Juliana.
And my name's Katharina. And our product is Coral Nurseries.
Our presentation is about coral habitat destruction. The reason behind us doing this project is due to the destruction of coral reefs, which is now affecting our oceans. So to try and help, we're trying to build a coral nursery to help the endangered coral. The coral destruction is caused by the warming temperatures and carbon dioxide in the seawater, and because of that, it can cause them to expel the microscopic algae that produces the food that they need.
The reason why we need to keep the coral reefs is because they provide an important ecosystem for the life underwater. They help protect coastal areas by reducing the amount of power of waves hitting the coast. Coral reefs teem with diverse life. You can find thousands of different species living on one reef. Healthy coral reef provides habitat, feeding, spawning, and nursery grounds for over 1 million aquatic species, including commercially harvested fish species.
Coral farming is when people grow coral in a safe space like a nursery, and after move it back into the ocean to help the reefs grow again. To coral farm, you take a small piece of healthy coral and let them grow bigger, where they're protected from pollution, animals, and temperature changes. Coral farming is very important because coral grows very slowly on its own. So farming helps speed the process. It also helps rebuild the damaged reefs and give sea life a safe place to live again. Coral farming works together with coral nurseries like the one we made to try to restore the reefs.
We built the coral nursery with an old tank that we recycled from our school to give it a new life. First, we put water in the tank and used instant sea salt to clean the water and lower the calcium. To build the actual nursery, we made homemade sculptures to help the coral grow on them. We used mainly natural ingredients like mud, rocks, and gravel for our sculptures to make sure we weren't adding more waste into the ocean, since that's what we're trying to prevent.
In conclusion, coral reefs are very important to ocean life, but they're being destroyed by human impacts like climate change. But by making coral nurseries and coral farming, we can help restore reefs, but we also need to fix the bigger problems to truly protect our oceans. That's the end of our presentation.
Okay, thank you, Coral Nurseries. Does anyone have any questions for Coral Nurseries? Anyone? Okay. All right, Coral Nurseries, where are you? Where's your station? Your station's over there. Okay, so if you have questions for them, they will be right there. They'll be able to answer all your questions. Okay, all right. So, Marc-André, did you get all that?
Oui, j'ai tout entendu ça. J'ai vu aussi les coraux. Moi, j'aime beaucoup les couleurs. I just like those colors in corals. It's the best thing in the world.
Oui, non, c'est vrai, il y avait des belles couleurs, le corail. Est-ce qu'il y a des gens qui sont francophones qui auraient des questions pour Coral Nurseries? Peut-être en ligne, je ne sais pas.
Pour l'instant, je ne vois personne vraiment en ligne. Peut-être qu'il y a quelqu'un qui regarde aussi les commentaires sur la page YouTube que je ne regarde pas tout de suite. Je me promène un peu entre les deux, puis c'est certain qu'il y a comme un 30 secondes là, de lag finalement entre ce qui se passe tout de suite puis ce que je vois sur YouTube. C'est la seule façon où je suis capable de voir le stage. Mais écoute, c'est super.
OK, parfait. All right. Well then, on va inviter la prochaine équipe, Team Glacier, à venir s'installer sur la scène. So Team Glacier, please prepare yourself on the stage here for your presentation. En attendant qu'ils s'installent, Marc-André, aurais-tu une blague de papa à raconter?
Une blague de papa? Ouf, bonne question. Moi, tout ce que je pouvais penser dans tout ça, c'était... C'est quoi, j'ai même pas de blague de papa de préparer. Prends tout, c'est drôle.
Ah ben moi, j'en ai une.
Ben vas-y.
OK, parfait. OK, what kind of fish performs brain surgery? A neurosurgeon.
Hein,
elle est bonne, hein? Il faut y penser.
Elle est bonne.
Yeah, all right. Alors, Team Glacier, on est prêt? Parfait, all right. You're ready. So, Team Glacier, everybody.
Hi, we are Team Glacier, and we have been working diligently to envision, design, and model some technology that we believe will have a significant positive impact on our chosen topic. And that topic is MSX, or multinucleate sphere unknown, is a deadly non-human harming disease in oysters caused by the parasite Haplosporidium nelsoni. It causes high mortality, about 90 to 95% in cultivated wild oysters, notably impacting the Eastern Canadian industry. It thrives in high salinity, warm waters, and typically causing peak losses during the summer, and has been present in the Atlantic since at least the 1950s. And started to affect Nova Scotia back in 2002 and has been detected in PEI as well as New Brunswick and Quebec as early as 2024. And we have come up with two solutions to detect and prevent MSX from cultivating in our base. Here are these ideas now.
Good morning. My name is Sophia Peach, and as a team, we identified a number of topics that we could research and to present in this Brilliant Blue competition. Collectively, we narrowed it down to a pressing matter that is affecting our wild and farmed oyster population, with specific reference to cultivation sites located in and around Cape Breton Island. Through much discussion and research, we came to a conclusion that the best methodology to deal with this parasite was to engineer a device for early detection. This device will mainly collect small samples of seawater over the to-be-announced cycle of time in the apparatus which the apparatus would collect, analyze, and then upload it to a research facility. The device's main purpose is to search for the parasite MSX. As well, it would monitor seawater, acidity, salinity, and temperature. The device would be deployed in areas that are a potential site for oyster cultivation. Oysters typically thrive in salty water with an ideal salinity range of 10 to 28 parts per thousand, and thrive in temperatures ranging from 20 degrees Celsius to 36 degrees Celsius, but it can tolerate temperatures as cold as 3 degrees Celsius and as high as 49 degrees Celsius for short periods of time. Bell will now speak to Orbed's engineering and components. Orbed stands for Ocean Remote Blue Early Detection.
Hello, my name is Belle Morant.
I'm here to talk about the engineering and components of Orbed. The primary capsule is a clear Lexan cylinder. The circumference is 6 inches and the height is 10 inches. It has a vacuum-sealed bottom. There is approximately 1.5 kilograms of ballast to ensure vertical stability when deployed at mooring. As an autonomous sampler, it is powered by a 5-volt mini round solar cell panel, which supplies and maintains photovoltaic energy to a primary inverter, which then supplies and maintains an onboard battery cell pack to power a small fluid pump with an internal pre-filter at 4 microns. A mini mass spectrometer designed and calibrated for the specific needs of the research target. Backwater valves for inlets and exit ports where the seawater samples will be integrated. A temperature gauge. The mass spectrometer will analyze for the parasite, record salinity, and pH. On board, there will be a transmitter that will record and then transfer to a satellite, Tritronics by Garmin, also powered by the solar cell array. Then the data is received by the research team. We envision a small fleet of these devices deployed at mooring in potential and previously surveyed bays, inlets, and other suitable environments. They will be moored in place, and we plan to conduct a survey in a series of 3 to 4 week intervals. At this point, manual servicing will be required. Barnacles, growth, debris, algae, etc. will need to be removed. At that time, the device will be taken on board of a research vessel, most likely a Zodiac rib, for the servicing, recalibration, and redeployment. The ocean is a harsh environment that does not discriminate. Currently, as of 2026, this world's smallest mass spectrometer is the Microsaic 3500 MID, which is still a laboratory bench model. But there are future developments on the horizon, miniature double-focusing analyzers that are extremely small as 3.5 centimeters by 6 centimeters by 7.5 centimeters, weighing under 1 kilogram or are currently being developed.
As a team, we recognize that the current methodology of growing oysters at a marketable abundance rate is unsustainable and will become unproductive in the very near future, unless new technologies and new methodologies are developed. We re-envisioned an oyster cultivation through a sustainable lens, using solar, wind, and geothermal technologies in conjunction with Orbed. We could fully manage a large area in which all growing conditions would be controlled through a series of interventions. This would create the ideal conditions that Mother Nature needs help with. Through our diorama model, we can illustrate our vision in its entirety. The research shows that oysters require temperatures between 20 degrees and 30 degrees Celsius. With this knowledge, we have a starting point to create these ideal conditions by a controlled engineering process that is sustainable. We propose using a series of 25-ton geothermal floating coils powered by industrial compressors so we can manipulate the temperature of the water in the grow area to its optimal range for growth of oysters. The excess heat, if produced, will run through a system that will set the salinity to the optimal range and adjust the pH before the water is returned. This collect and return system will be managed by a series of water flow check valves. By manipulating these 3 factors, temperature, salinity, and pH, on a continuous basis, will restore a habitat suitable for oyster cultivation. When the MSX parasite is detected by Orbed, steps can be taken to prevent infection. For example, if the oysters are being grown in suspended baskets, those oysters could be relocated quickly to an MSX-free body of water efficiently and in quick order.
As noted earlier in the presentation, oyster cultivation is a significant and notable economic driver to the Atlantic region, along with promoting local areas associated with this industry, which has significant spin-off effects. Maintaining biodiversity and ecosystems in general has a net positive impact on the health of the planet as well as its economic contributions. The more we understand marine ecosystems, the better positioned we are to rehabilitate, restore, and avoid any future human-made problems. When we have a healthy ocean, Humans can thrive from its bounty, and sustainable harvesting practice will bolster economic markets. As we are in the midst of a transition and recognition that the blue economy benefits the planet, we are better positioned to address challenges that climate change has brought into focus. A healthy planet means a healthy economy. Any research and technological advancements that help the planet in this time of crisis should be warmly received and employed as soon as possible, as the crisis is only worsening. As our project is theoretical in nature, there is no physical process to conduct sea trials for our prototype. Our intention with this prototype is to give a visual/concrete model that can illustrate its engineered concept. Once the analyzing technology advances enough to be incorporated into our design, then we can move forward with real-world testing scenarios. As for the engineered nursery proposal, professionals and academics in the field need to debate its potential and shortcomings and hopefully make it a viable reality.
Do we have any questions?
I did have one, but you answered it quite well at the end there, saying that it's kind of, I guess, the sea trials for the future. So in your, I guess, best hopes and dreams, what might those timelines look like? Are you hoping that maybe there'll be some advancements in the analysis side of things for the data to have something viable in the next year or two? Or because I'm echoing, I guess, what you mentioned, like it's devastating for certain oyster beds. I've got family and friends in PEI, and I've seen the impact, so just kind of curious.
We are hoping from any time in the next year to the next 5 years that this will be possible.
Any other questions? Est-ce qu'il y a des questions?
Thank you for your time.
Oh, Team Glacier, I think you forgot your, there you go. Not a problem.
Patrick, tantôt tu m'as eu.
Oui.
Tu m'as eu, j'étais pas prêt. But what you might not know is when I was younger, when I was about, even younger than these guys, right now it's le Salon du Livre. It's the book fair in our area. And every year I would buy a new book. And I actually have them all with me. You probably can't see my camera, but it's right there, okay? I'm moving them so you can't see them. And those are all what we call histoires drôles, toutes des livres de blagues. Okay. And I actually found one joke in the number one, dans le premier livre que j'ai acheté. It's Histoire drôle number one, and I want to ask it. Yeah, let's go. So, il est en français, bien sûr. Donc, quand un électricien va se baigner, qu'est-ce qu'il fait?
OK.
Il suit le courant.
Oh. Oh. Elle est bonne.
That's a 20-plus-year-old joke right there.
It still works.
In the original. Yep, exactly.
Ça marche toujours. OK. Well, merci beaucoup, Team Glacier. Thanks, Team Glacier. So now we're about ready for the next team, Aquadragon. L'équipe Aquadragon, est-ce qu'ils sont en virtuel ou ils viennent sur le stage? Est-ce que vous venez sur la scène? Are you virtual? Oh, they're right there. Okay, perfect. Okay, perfect.
Oui. J'aimerais leur dire allô. They're from Edmonton, and that's where I am right now. So, well, Rivière-Verte. So, hi.
On a des brayons. OK.
Oh yes.
Allez-y les filles.
Bonjour, je m'appelle Arielle Villeneuve et voici ma collègue Olivia Thériault. Nous allons vous présenter l'aquaculture. C'est quoi l'aquaculture? L'aquaculture, c'est élever des poissons, des crevettes ou des algues dans des bassins, des étangs ou en mer. Un peu comme cultiver des légumes dans des jardins. Elle sert à produire de la nourriture et à les poissons sauvages, à protéger les poissons sauvages. Parce qu'on peut les élever sans trop les pêcher dans l'océan. En résumé, ça fait pousser des animaux, des plantes dans l'eau pour les manger ou les vendre, de façon contrôlée et plus sûre pour la nature. C'est quoi un aquadragon? Il fait partie de la famille des crustacés depuis des millions d'années. Son nom scientifique est Artemia salina et il vit dans les lacs et les mers salées. Il a une sorte de Ses nageoires fonctionnent comme une sorte de branchie et il a une sorte de petite structure qui ressemble à des petits poils. Il peut faire 3 choses en même temps, manger, nager et se guider dans l'eau. Les aquadragons ont un rôle très important dans la nature. Ils sont des nettoyeurs naturels. Ils mangent des algues et des petites particules dans l'eau, donc ils aident à rendre l'eau plus propre. L'équilibre dans l'écosystème. Ils font partie de l'écosystème des lacs salés, des mers salées, donc il y aurait des animaux qui n'auraient pas de nourriture. Ils servent de nourriture pour poissons, oiseaux aquatiques et petits animaux marins. Donc, ils sont au début de la chaîne alimentaire. Comme vous pouvez voir, ils sont le deuxième rang, comme vert. Là. Que faut-il pour que les aquadragons éclorent? Les aquadragons, leurs œufs restent ainsi endormis, parenthèse, hibernation profonde, sans eau jusqu'à ce qu'on les mette dans un environnement plus favorable. L'eau doit être légèrement salée, de 24 à 26 degrés Celsius, et ils ont besoin d'avoir de la lumière pour se nourrir et se développer. Quand ces conditions sont réunies, ils pourront grandir normalement. Le problème principal est l'utilisation massive de farine de poisson produite à partir de poissons sauvages comme les anchois et les sardines. Cette pratique entraîne la surpêche et perturbe l'écosystème marin, car ces poissons sont essentiels dans l'écosystème marin. Solution. L'Artemia salina est de la nourriture pour plusieurs sortes de poissons, comme les saumons. Ses avantages est déjà écologique et économique et déjà dans des magasins déjà existants et est déjà durable. Il réduit les empreintes carbone. Si on utiliserait les aquadragons à la place de la farine de poisson, il y aurait 35% moins de surpêche, 80% moins de CO2 et 40% et plus de larves qui survivraient. Moins de surpêche, moins de CO2 est égal à plus de poissons. Plan d'affaires. L'aquaculture actuelle est peu efficace à cause d'une forte mortalité des larves et d'une nourriture mal adaptée, ce qui entraîne du gaspillage de ressources. L'utilisation de l'Artemia améliorerait l'efficacité en réduisant une nourriture mieux adaptée et réduisant les pertes et les coûts. Malgré un investissement initial élevé, le système deviendrait rentable vers la 4e année grâce à la production, croissance et au plus être rentable pour les aux économies réalisées par les pisciculteurs. En plus d'être rentable vers la 4e année, la production locale permet de réduire les coûts et stabiliser les marchés et diminuer l'impact environnemental. Comme vous pouvez voir, dans le milieu, ça serait notre bassin d'élevage. Puis à votre gauche, en haut, on a les bassins où on éclot et on élève les cystes. Les cystes, c'est des œufs. Et puis, en droite en bas, on a les bassins où on élève les... on produit les micro-algues pour nourrir les aquadragons. Et puis, après, on a le recyclage d'eau. Et puis, À votre droite, en haut, on a où qu'on surveille avec les caméras et tout. On peut contrôler la température, le pH, la salinité, l'oxygène. Puis aussi, en dessous, c'est où qu'on produit les sachets puis tout pour les emballer et les envoyer dans les marchés et aux pisciculteurs. Étant donné que notre projet peut être personnalisé, il est difficile de mettre un prix exact selon la quantité. Fait que tu as 50 à 150 individus par litre.
Équipement. On a besoin de le bassin de culture, le bassin d'éclosion, des pompes à air industrielles plus aérateurs, le système de filtration, l'éclairage LED contrôlable et le chauffage de température. Au total, ça nous donnerait entre 8 000 $ à 37 000 $.
Comme que vous pouvez voir, ici, on a un autre tableau. Là, c'est l'automatisation morning. Le morning, c'est comme un système. Ça coûterait 3 500 à 16 000 $.
Approvisionnement en matériel premier. C'est tout ce qu'on aurait de besoin pour commencer. Premièrement, les œufs d'Artemia, le milieu de culture, la nourriture et les réactifs tests. Au total, ça ferait entre 825 $ à 3 420 $.
Coût d'exploitation annuel. Fait que ça serait par année que ça coûterait. Fait qu'on a l'électricité, la main-d'œuvre qu'on surveille et tout. Et aussi, on a le réapprovisionnement de l'œuf, des œufs et de la nourriture. Et on a la maintenance et les pièces d'équipement. Fait que ça serait de 23 000 à 76 000 $ par année.
Un système bien géré peut produire 100 kg à 500 kg d'artémia vivant par an, selon le niveau d'intensification. Prix de vente sur le marché commercial, c'est tout ce qu'on pourrait vendre, comme des artémias vivants, des cystes de haute qualité, des produits enrichis. Au total, ça ferait entre 2 500 $ à 50 000 $. Et si ça serait plus enrichi, on pourrait aller jusqu'à 90 000 $. Si on regarde bien le tableau, on peut voir qu'à la 4e an, on rentre complètement dans notre argent.
Conclusion. Pour conclure, l'artémia samna est une solution durable et stratégique pour l'aquaculture. Elle améliore la survie des larves, réduit la dépendance à la pêche sauvage et permet de produire une production plus locale, plus écologique. Bien qu'elle ne remplace pas totalement l'alimentation animale, ni ne sauve pas les océans à elle seule, intégrer un système intelligent et bien surveillé, elle contribue à une aquaculture plus efficace, rentable et respectueuse pour l'environnement.
Remerciements. Nous voulons remercier Mme Vanessa, Stéphanie Dubé et François Labrie, José Martin et Dean Terrouillot et M. Marc-André.
Références. Voici nos références. Merci et bonne journée. OK, moi je me sauve d'ici. Bye. La manette.
Est-ce que vous pourriez retourner au microphone pour une seconde? Ou peut-être je vais vous passer ce microphone ici. On a une question. J'ai une question. Alors, j'ai peut-être manqué une petite partie de votre présentation. Super bel job. Le but d'élever les aquadragons, est-ce que c'est pour les remettre dans des écosystèmes ou pour créer de la nourriture pour d'autres animaux? Parce que j'imagine comme crustacés, ils ont beaucoup de protéines. Alors, ça serait quoi le but des élever?
Le but, ça serait de donner ça à des agriculteurs ou à l'aquaculture, des personnes qui créent comme qui nourrissent les poissons, à la place d'utiliser de la farine de poisson parce que c'est une nourriture mal adaptée pour eux autres. Et puis, ça leur donnerait une survie plus aux poissons, là, ça leur donnerait plus de survie, comme ils survivraient plus longtemps. Et puis, ça serait plus facile de les élever parce qu'ils seraient plus en bonne santé.
Merci beaucoup. Is there any other questions or questions? OK, merci beaucoup. Bonne journée.
Merci à Quadragon. Super présentation. C'est incroyable. C'était super. Oops. On purpose. OK. All right. So, merci à Quadragon. Marc-André, as-tu aimé la présentation?
C'était excellent. C'était digne d'un vrai Brayon.
Bon. Parfait. Alors, without further ado, we're going to move on to the next team. On va bouger à l'autre équipe. Innovation bleue. Innovation bleue. Are they virtual or? Okay, all right. So they're online. So, Marc-André, je te laisse présenter.
Excellent. Alors, l'équipe Innovation Bleue qui viennent de la province du Québec, ils sont inscrits dans la catégorie vie marine saine. Ils devaient être ici à 11h20 selon notre horaire. Donc, je ne les vois pas présentement dans la salle. Donc, je crois qu'on va attendre un tout petit peu.
Parfait, pas de problème.
Je crois qu'ils sont dans l'autre salle, donc il va falloir qu'on attende que Brandon les place dans la salle de présentation.
Okay.
Brandon, it would be time to send Innovation Bleue in the main room.
In the meantime, Marc-André, do you want a dad joke? I have one for you.
Sure.
Okay.
Oh, yes. Go ahead.
Okay, so let's see here. Okay, wait, hold on. Okay, why did the fisherman lose his job? His profits were net zero. Okay, all right, that was way too funny. All right. Est-ce que Innovation Bleue est prêt?
Ah, je les vois dans la première salle. Mais ils ne sont pas dans la salle où est-ce que je suis présentement? Donc, we are waiting to be able to see them.
Just going to do a crowd check. Is everybody having fun right now? Everybody like learning stuff? I'm learning a lot. Like I am. Like, congratulations. Félicitations à tout le monde. Là, vraiment, vous m'impressionnez. There's hope. It's awesome. It's great. Ah. Et puis, comment ça va avec l'Innovation Bleue? Ça s'en vient?
Je crois que ça s'en vient. Ils viennent d'apparaître dans la nouvelle salle. Donc, bonjour, équipe Innovation Bleue. Est-ce que vous m'entendez bien?
Oui.
Excellent, super. Donc, vous pouvez allumer votre caméra et vous pouvez aussi partager votre présentation si vous en avez une. Vous allez remarquer dans la présentation, en même temps, il y a à la droite, il y a un petit compteur là, qui est écrit 10. Donc, vous avez le 10 minutes. Je vais le commencer quand est-ce que vous serez prêt. Donc, j'ai hâte de voir l'équipe Innovation Bleue. Vous venez du Québec, c'est ça? Dans quelle ville?
Nous venons de Laval.
De Laval. Excellent. Écoute, c'est pas loin de Montréal, ça, je crois.
Non, c'est ça, c'est juste à côté.
Ah, excellent, super. Ça me mélange tout le temps parce que l'Université Laval aussi, puis l'Université Laval est à Québec finalement. Là, je viens tout mélanger là-dedans.
Les universités sont un peu éparpillées.
Excellent. Super. Alors, je vous laisse la parole. On y va avec équipe Innovation Bleue.
Parfait, merci. Donc, je nous présente, on est l'équipe Innovation Bleue. On est une équipe composée de 5 membres, donc moi-même, le vice-président Nathan Kowski.
Sinon, moi, je suis Zoé Tremblay, je suis la présidente d'Innovation Bleue.
Je m'appelle Nicolas Beaulieu, je suis directeur des technologies.
Moi, Sophia Ilieska, je suis directrice des opérations.
Nous avons aussi une 5e membre, Alice Raymond, qui malheureusement ne pouvait pas être là pour la présentation. Et nous avons aussi 2 mentors, donc Jean-Pierre Dufresne, conseiller d'innovation pédagogique qui nous appuie dans le projet, et Félix Morin, président de l'entreprise Succès scolaire qui nous guide à travers toutes nos difficultés.
Alors, notre projet, tout simplement, c'est un jeu vidéo. Pourquoi bien un jeu vidéo, vous nous demanderiez? Bien, en fait, c'est que parce que notre public cible, elles sont les jeunes de 12 à 17 ans. Et quel meilleur moyen d'aller rejoindre ce public cible que par un jeu vidéo? Alors, c'est un jeu vidéo qui va aller toucher les enjeux des fonds marins et à travers les cours de sciences, géographie, même potentiellement en CCQ à travers des enjeux éthiques. Donc, nous voulons vraiment, à l'aide de notre jeu vidéo, aller enseigner aux jeunes plus à propos des fonds marins. Donc, parce que c'est un enjeu extrêmement important au Québec, au Canada, car nous avons un grand pourcentage des eaux douces. Alors, nous croyons que c'est extrêmement important, mais malheureusement, le système scolaire ne l'enseigne pas vraiment. Donc, à travers les cours de sciences, géographie, nous voulons vraiment aller intégrer de la matière en plus d'apprendre aux jeunes comment aider leur cours d'eau. Car c'est impossible de changer le monde si personne ne sait qu'il doit être changé. Alors, c'est impossible d'aider les enjeux des fonds marins et des cours d'eau si personne ne sait quels sont les enjeux.
Donc, nous aimerions premièrement offrir un outil pédagogique aux profs, donc une plateforme à travers laquelle ils peuvent accéder à des ressources pour les profs, à des travaux préfaits pour leur simplifier la vie et vraiment réduire le temps dans lequel ils sont obligés de prendre pour se préparer, faire leur plan de cours et tout ça. Donc, vraiment rendre ça rapide. Et nous aimerions aussi sensibiliser les jeunes à travers quelque chose qu'ils aiment faire. Tu sais, c'est sûr que si tu mets un jeune devant un papier qui parle des fonds marins pendant 1 heure, il va arrêter d'écouter. Si on commence à lui donner un jeu dans lequel il peut s'amuser, c'est sûr que ça sensibilise beaucoup mieux.
Nous allons aussi tester notre jeu vidéo en l'implantant notre application en version un peu test, afin que les écoles puissent un peu voir qu'est-ce qu'on a à en faire. Pour l'instant, on va commencer à l'intérieur de notre école. Ça va être plus simple pour les tests. Et on organise aussi, dernièrement, on a fait une couple, des rencontres avec des professeurs à notre école qui nous ont aidé un peu à voir qu'est-ce qu'il y a de matière qu'on pourrait aborder dans le jeu vidéo. Puis on a des membres de notre équipe qui sont allés visiter des locaux d'Ubisoft et qui ont eu une rétroaction s'ils veulent partager.
Oui, en fait, récemment, moi, Sophia et Alice, Raymond, la membre qui n'est malheureusement pas là aujourd'hui, nous avons eu l'opportunité d'aller voir les studios d'Ubisoft, donc faire un tour de le studio, mais nous avons aussi eu l'opportunité de leur présenter notre jeu vidéo. Donc, nous avons eu la chance de faire un pitch, comme on peut appeler ça, devant plusieurs employés d'Ubisoft, et grâce à ça, nous avons eu beaucoup de retours en action, des conseils, etc., de professionnels en jeux vidéo. Donc, c'était extrêmement instructif. Alors, pour nos jalons ou les milestones, comme on appelle communément en anglais, il y a l'idéation, recherche, conceptualisation. En fait, nous avons déjà fait une bonne partie des jalons. En ce moment, je dirais, nous sommes plutôt dans l'action. Donc, on va vraiment essayer d'aller chercher plus de ressources. Nous essayons, mais justement en faisant ce concours, c'est ce que nous essayons de faire, aller chercher plus de ressources afin de pouvoir créer notre jeu vidéo. Sinon, les choses qui nous restent vraiment plus à faire, c'est l'élaboration et la réalisation de notre jeu vidéo. Donc, on est vraiment entre la phase où on réfléchit à ce qu'on veut faire et celle où on commence vraiment à le faire. Alors, c'est très intéressant, je trouve.
Donc, nous allons poursuivre avec notre budget. Donc, on a été très chanceux de recevoir 10 000 de la part de Succès scolaire. Donc, ça, c'est notre budget pour la réalisation de notre projet. On va surtout essayer de le respecter pour pouvoir atteindre notre break-even point au plus tôt possible. Donc, comment nous l'avons divisé? Alors, d'abord, pour la programmation, on a prévu 2 310 par an. Donc, ça va être consacré pour l'utilisation de Unity, qui est le logiciel que nous souhaitons utiliser pour développer ce jeu mobile. Ensuite, pour le marketing, c'est un coût variable, donc c'est une approximation, mais nous prévoyons environ 1 500 $, donc ça va être surtout pour des publications sur les réseaux sociaux, des partnerships avec des organismes environnementaux et ainsi des événements promotionnels. Sinon, pour le design graphique et sonore, nous prévoyons environ 2 000 $, donc nous aimerons avoir l'embauche formelle d'une graphiste et aussi d'avoir l'achat de musique. Sinon, pour le contenu éducatif et le coaching, nous prévoyons 1 200 $. Nous avons déjà utilisé une partie de ce montant avec Succès scolaire. Nous avons reçu beaucoup de mentorat avec Félix Morin, leur président. et nous prévoyons utiliser le reste de ce montant pour avoir des consultations avec des experts en environnement et aussi des enseignants des directions de niveau pour s'assurer que notre application est le plus conforme aux apprentissages de l'élève en classe ainsi que son cheminement. Sinon, pour les tests et améliorations, prévoyons environ 500 $. Donc, nous allons faire des tests à l'interne, mais nous aimerions aussi que nous ayons des rétroactions à l'externe aussi pour apporter n'importe quelle amélioration possible. Ensuite, pour l'obtention d'un domaine, c'est 25 $ par an. Ensuite, pour les frais de mise en ligne sur l'App Store, comme c'est un jeu mobile, ça va être 99 $ par an. Et sur Android, ça va être 25 $ payé une seule fois. Ensuite, pour le stockage Firebase, qui est dans le fond notre base de données, c'est environ 150 $, mais aussi ça dépend avec la taille de notre application. Et ensuite, les frais GitHub, qui est dans le fond la sauvegarde de notre projet, c'est 96 $ par an, ce qui nous laisse avec un reste de 2095 $ pour n'importe quel imprévu.
Nous avons certaines attentes dans les prochaines années, 1 ou 2 ans d'année. Et ces attentes-là sont dans le fond que notre application soit intégrée dans notre école, le Collège citoyen, ainsi que 2 autres de ces écoles partenaires, le Collège de Tente et le Collège Boisbriand. Et nous aimerions aussi qu'il y ait 12 classes actives, donc 12 licences de vendues et que les professeurs utilisent notre application avec leurs élèves. Et ça nous rapportera environ 2160 $ en revenus qu'on puisse payer toutes les dépenses qu'on a à faire, si bien présentées dans le budget juste avant. Donc, dans le fond, tout ce qu'on veut, c'est juste que les jeunes aient une bonne conscience écologique envers les cours d'eau et qu'ils savent comment en prendre soin.
Donc, pour nous contacter, nos 2 réseaux sociaux sont sur l'écran. On est sur Instagram et Facebook et vous pouvez toujours écrire un courriel au bleuinnovation@gmail.com.
Vraiment, n'hésitez pas. Ça va nous faire plaisir de répondre à n'importe quelle question ou même vraiment, dès que vous avez une question, vous désirez nous parler de notre projet, peut-être même que vous pensez que ça pourrait être quelque chose de bien des prochaines années pour votre école, n'hésitez aucunement à nous contacter, ça va nous faire plaisir.
Merci.
Oui, merci, au revoir.
Merci.
Merci beaucoup, équipe Bleu Innovation. Quelle belle présentation. En plus de ça, hey, c'était même en français et en anglais. On voit que vous êtes fluent dans les 2 langues.
J'ai une question pour Innovation Bleue. Est-ce qu'ils sont encore en ligne?
Oui, ils sont encore là.
Oui, d'accord. Alors, je suis graphiste moi-même. Alors, je vous pose la question, quel niveau de graphisme est-ce que vous recherchez à avoir dans votre jeu vidéo?
Donc, pour l'instant, on va avoir surtout un niveau de base et on compte utiliser des ressources qu'on a. Donc, on a contacté certains élèves à notre école qui sont bons en dessin. Et c'est d'ailleurs une des élèves en particulier, elle a fait le fond d'écran de nos iPads. Donc, on compte avoir quelqu'un de proche. Donc, c'est pour ça que le budget pour cela était plus bas que peut-être ce que vous aurez attendu.
C'est sûr, pour l'instant, on est encore en début, donc on commence. Mais on est très content d'avoir réussi à trouver cette ressource-là. Donc, cet élève, elle décide super bien. Alors, même si ce n'est pas une graphiste professionnelle, on pense que pour l'instant, ça ferait très bien à faire et c'est même très joli.
Parfait, merci. Any other questions for Innovation Bleue? Des questions pour Innovation Bleue? All right, well, merci beaucoup, Innovation Bleue.
D'accord, merci énormément. Bonne journée.
All right, for the people present here, I want to specify, outside we have a photo booth. If you want to take a picture and post it on social media, it's available there. We also have jet boat races, so you can participate in that as well if you like during in between presentations whatsoever. And we also have an anthem for Real Blue. And this anthem, while it will play, it will announce lunchtime. And then after that, when the anthem will play again, it will be get back to your seats. We have to do the presentations again, just like in school. So, je vais réexpliquer en français. Donc, on a, c'est pas ça. Ça, c'est pas l'anthem. That's not the anthem for Real Blue, by the way. This is just, it's something different.
Non, c'est de ma faute. J'ai oublié d'arrêter le timer.
Ah, d'accord. Alors, pour les francophones, on a voyons comment on dit ça, une photo booth en français. Ça fait trop longtemps que je reste au Nouveau-Brunswick, j'ai aucune idée. Mais vous pouvez prendre des photos dans cette salle-là. Il y a un endroit où on prend des photos, puis poster ça sur les réseaux sociaux. Et on a aussi des courses de bateaux téléguidés. Alors, donc, vous pouvez vous inscrire à ça. entre les présentations ou avant le lunch ou pendant le lunch aussi. On a aussi un anthème, un thème pour bleu brillant. Et puis, lorsqu'on va faire jouer le thème bleu brillant, ça veut dire que le dîner va être servi. Et lorsque le thème bleu brillant va rejouer encore, ça veut dire qu'il faut retourner à nos sièges pour les prochaines présentations. D'accord? All right. I feel like a principal or something. It's fun. Okay, so we're getting ready to welcome the next team, the Citric. Oh, I'm sorry about that. The Citric. Marc-André, tu es capable de dire le nom? Tu vois-tu le nom de l'équipe qui s'en vient?
Disintegrable Lobster Trap.
I'm sorry, girls. We're trying. Okay.
We're francophone here.
Yeah, but you can come and set yourselves up here. We'll be talking until you guys are ready. Not a problem there. All right. So so that was a good idea there for Innovation Bleu there, the video game. I was really interested with that. I'm a gamer myself. Any gamers in the room? Wow, I thought it would be a lot more. Okay, well, I feel all alone now. All right, good.
Well, what do you consider a gamer, though?
Well, if you don't know what gamer means, you're not a gamer, Marc-André. Well, there you go. All right. Okay, so do you want a trivia again?
Yeah, sure.
Yeah, okay. So let's see here. What is a process called where deep, cold, nutrient-rich water rises towards the surface to replace water pushed away by winds? Any guesses in the room? Oh. No, that's not it. I'm sorry. Oh, okay. All right. Okay, well, the answer to the question is upwelling. And I'm happy to announce that the name that's on the schedule is not right. The name of the team is Biodegradable Lobster Trap. Thank you so much. All right. Okay, so are you guys ready to hear that presentation before lunch? Let's do this. Let's go.
Hello, I'm Abigail. And I'm Kara. And we did a biodegradable lobster trap. Our project contains overview, objectives, material, construction, pros and cons, conclusion, and resources. Our overview, a biodegradable lobster trap is designed to mitigate the environmental impact of ghost fishing, where lost and abandoned fishing gear continues to trap and kill marine life indefinitely. These traps feature components that degrade over time in marine environments, allowing trapped animals to escape if the trap is lost. Objectives: minimize marine population by using materials that naturally break down in salt water, untreated wood, natural fiber, rope, biodegradable plastics. Reduce ghost fishing. When lost traps keep catching animals by ensuring the trap degrades or opens over time. Protect marine ecosystems by avoiding toxic coatings, metals, or synthetic plastics that persist in the ocean. Our materials. We used wood, we used maple and spruce wood, we used nails, staples, galvanized utility wire, plastic coated. That would be our only non-biodegradable material on our lobster trap. We used biodegradable twine, biodegradable netting, cordless drill, cement, manila rope, hammer, tacker, electric sander, handheld planer, chop saw, rotor, air nailer, air stampler, sander, drill press, construction paper. Our trap construction. For the first step that we did to build our trap, we built the frame for the trap. And then we attached our biodegradable netting, and then we added the escape panel that breaks down over time. And then we added the entrance with the metal wire, which is the only thing non-biodegradable on our trap. And then we made a funnel out of biodegradable string. Analysts, biodegradable lobster trap. This is comparing a biodegradable lobster trap to a normal lobster trap.
Our biodegradable lobster trap weighs 24 pounds without the concrete and 26 with the concrete. We didn't add the concrete yet, but the size is 36 long, 13.5 height, and 22.5 width, which is in inches. It's good for the environment, made out of wood, homemade. It will last a couple of years or so, but the string will only last a couple months. It's better for the ocean and keeps more animals alive longer. Normal lobster trap weighs 125 pounds when wet. Size is 24 inches to 36 inches, or 28 to 48 inches. Not good for the environment, made out of plastic. It can last forever. It's worse for the ocean, kills the animals faster.
Our pros and cons. Pros, it lowers environmental cleanup costs. Its potential compliance with stricter future regulations, use of locally sourced materials, wood and natural fibers. Cons, shorter lifespan, more frequent replacement, potentially higher long-term cost if durability is too low, labor costs for rebuilding traps.
Conclusion. In conclusion, uptaking biodegradable lobster traps help protect the marine biodiversity, supports reasonable fisheries and management, and aligns with growing environmental conservation efforts. While there may be challenges related to cost, durability, and widespread use, continued innovation and regulation can make these traps a standard in the university. Ultimately, they offer a balanced solution that maintains economic visibility for fishers while safeguarding ocean health for future generations and discrees ghost fishing.
And most of the time, like a biodegradable lobster trap, it normally takes 2 to 3 hours to like build and do the netting and everything. And for the resources, we used my uncle, like our main resource, we used my uncle who was the professional fisherman.
That's it.
And yeah.
Okay, thank you, biodegradable lobster trap. Love your name. So, any questions for biodegradable lobster trap? Yes, ma'am.
Oh yeah, sure. Okay, yeah. We can explain it.
We can explain how it like works and how the lobsters get into it and how the small ones like exceed. Okay, so
there's the entrance for the lobsters to go into.
It's on both sides as well.
Yeah. And then you go into here. There's like a funnel made out of the fishing net. And then they go into there. And there's a trap to the lever thing to open up and you get the lobster.
Yeah. So what the lobster does, it's going to climb into here. And then the bait will be in here. So the lobster will go up the funnel and into the trap itself where the bait is. But like little ones don't like provide much. So the little ones can like escape through like the openings and stuff like that.
Took us 3 to 4
Yeah,
hours
it took us a
probably.
little bit longer than what like a fisherman would do because like they do that as a living basically. And this was our first time doing it and we had help. So I'd say it took us about like 3.5 hours.
Yeah, thank you.
I also have a question. Yeah. For fishermen, when they use lobster trap, regular lobster trap, how long do they last?
So the first thing on our trap that would like degrade basically would be the
this
netting.
netting right here.
So, and then the wood, it's going to take the wood a few years as well. And then for the nails that we use, those would just rust. And then like, yeah.
They'll eventually disintegrate, but they'll
Okay, because I'm wondering, because fishermen, it's a hard life, right?
Yeah.
So to actually have to invest into netting, is that a viable solution? Or?
Well, it would definitely like decrease ghost fishing for
and,
sure.
Waste in the ocean.
And the waste
from
in the
traps.
ocean.
Perfect.
From traps that are getting lost.
Perfect. Thank you very much. All right. Okay, so these were the presentations for this morning, but it's not quite lunch yet. Okay, so let's not all rush over there. Ah, I'm hungry. No, it's not happening. So what I'm suggesting to do is, as you can see, there's stations all around the wall here, and you're all innovators. So let's just go and mind meld. Like, let's just share stories. Let's share ideas. À tout le monde, vous voyez qu'il y a des stations de chaque côté de la salle. Allez voir, visiter les tables. Allez voir qu'est-ce qui se passe chez les autres équipes. Ils ont peut-être, comme Jeff a dit ce matin, ils ont peut-être des idées pour vous. Okay? So let's do that. And once the anthem will play, that means it's lunchtime. Alors, quand le thème de Brown Blue va jouer, le bleu brillant, c'est l'heure du lunch. Alors là, vous vous dirigerez dans le lobby pour avoir votre lunch. Okay? And don't forget, during the lunch, you can take pictures of the photo booth, or you can try your pilot skill at the jet boat races. Alors, pendant le lunch, vous pouvez aller soit prendre des photos dans la caisse à photos ou faire participer à la course de bateau. Tester vos talents de pilote. OK? Parfait. Hello, everyone. Sorry to disturb your conversations here, but we're going to play the anthem so you know what it sounds like. Okay. Okay, so when this plays, this means it's lunchtime. And when it plays again, it means lunchtime is over, and you come back in the room. Alors ça, c'est le thème. Alors lorsque vous entendez le thème, ça veut dire que c'est l'heure du lunch. Et lorsque le thème va rejoindre encore, c'est l'heure de revenir dans la salle. Okay? So right now, it's lunchtime.
Architects, the engineers, the truth. From a single ripple to a tidal wave, you're gonna hear the sound we've made. You're gonna hear the sound we've made. The future of the ocean is right here and right now. Keep talking about generation. You see the price of it, better than I'm doing.
All righty. I hope you guys had a good lunch. J'espère que vous avez eu un bon dîner. Il reste encore quelques minutes au dîner, mais on a une petite idée, nous, ici à Bleu Brillant. We had a great idea at Real Blue. Now that we have an anthem, I think it's time that we actually learn the lyrics. So what we're going to do is we're going to play the anthem, on va jouer le thème, and we're going to sing together. On va chanter ensemble. Isn't that great? Yes, Patrick, it's great. Yes, Patrick, it's great. Okay, perfect. All right. So, without further ado, let's play the anthem.
From every coastline, every city, every school, new waves rising. Yeah, we're breaking.
Okay, so this is a learning phase. We learn the song first, and then we sing after, right? Okay.
Do a different vision, shining, brilliant, shining blue. We are the innovators, we are the engineers. We're the scientists, silencing all the fears. We see the UN decade, we know the time is now. They ask who's gonna fix this. We're here to show them how it's more than just a project. It's more than just a prize. It's seeing the solution right before our eyes. For healthy marine life, for energy that's clean. The brightest minds the world has ever seen.
Okay, let's go.
We are genuine blue. We see the future and we're pulling it on through. Answering the challenge, brilliant blue. We're making our impact, showing what we can do. We are genuine blue. We innovate.
Okay, Neil, let's pause it for a second. Okay, so now let's try this. Let's go. We are. Come on. We are. Come on. Who's awake now? Come on. We are. Okay, so when it comes to we are, I want to hear we are. Are we okay with that? The answer was we are. Come on, guys. All right. Let's try this again. Let's go.
This is the mission, this is the hour. We code autonomous systems, we draw the master plan. The blue economy is rising in our hands. From the brilliant blue challenge to the labs across the sea, we are the ocean stewards for all the world to be. This isn't just a dream we're hoping will come true. It's the global force of me and you. It's more than just a contest. It's more than just a grade. It's for ocean sustainability. The promise that we made for marine energy. A vision clear and true. A global chorus shouting something new. We are Generation Blue. We see the future and we're pulling it on through. Answering the challenge, brilliant blue. We're making our impact, showing what we can do. We are Generation Blue. We are Generation Blue.
Okay, that last one was really pitiful. Seriously.
They call us the students, they call us the youth. They call ourselves the architects, the engineers, the truth. From a single ripple to a tidal wave, you're gonna hear the sound we've made. You're gonna hear the sound we've made. The future of the ocean is right here and right now.
Yes.
We're making our impact, showing what we can do. We are Generation
You guys are alive. Awesome. Right. Yes. Good job, everybody. Give yourselves a hand. All right. All right, well, while I have you in this room right now, we have Grace who would like to share her project. So I invite Grace to come to the stage, please, and talk about your wonderful initiative.
Hi, everyone. Okay, so I just wanted to come up real quick and kind of talk about the project I've been working on for a couple months now. So my name is Grace Hahn. I'm from St. John, New-Brunswick, St. Malachy's Memorial High School. I heard we have some St. John High School people in here, which is my rival school, by the way. Anyway, but I'm doing a project called 17 by 17. So 17 by 17 is my goal to implement all 17 of the United Nations Sustainable Development Goals in my community before I turn 17 this upcoming June through actions such as clothing drives, food drives, fundraisers, or basically anything that comes to mind. I'd say this all kind of started way back when I was like 10 years old, and I did an after-school biomaking program with Brilliant Labs. That program it was really fun because we were kind of like making stuff out of like SCOBY, which I know you probably don't know what that is, but it's basically symbiotic culture of bacteria and yeast. Anyway, I won't get into it. I'm very knowledgeable on that topic. But basically, it helped me realize that we have a lot of issues in our world, such as climate change and such as everything that's happening in the oceans that you guys are here to solve. And honestly, the first feeling I thought was not that I need to solve it, it was actually fear. And I didn't know how to solve it, and I was really scared. But as I got older, I realized that I can use my fear and put it towards something good to make a meaningful impact and change. So that's what I did with 17 by 17. So far, I've completed 12 of the goals within my community. One that I haven't mentioned, UNSCG number 4, quality education. I'm currently doing a podcast that interviews students just like yourself about their projects for the UNSCGs, and then we talk about the United Nations Sustainable Development Goals to try to educate people. So here at Brilliant Blue, we are actually currently, all of us are working on UNSCG number 14, Life Below Water, which I'm sure you saw on the slide that was just above while lunch was happening. So far, 17 by 17, we actually haven't done anything for UNSCG number 14, Life Below Water, but I'd love to share what the United Nations has done for that goal. So, some of the things include the United Nations has actually helped countries create marine protected areas. So that basically means areas that no one can fish, and it kind of just, so all the life below the water can stay safe. Also, over 60 countries have now pledged to reduce single-use plastic, all because of the United Nations, and the UN supports projects to monitor and protect coral reefs, which I know one of the teams in here knows a lot about coral reefs, and I forget which one. But yeah, that's some of the stuff the UN has done, and you guys are currently doing the exact same thing. So you can get involved with my 17 by 17 project if you go onto Instagram or any social media account and use the hashtag 17 by 17 challenge tag, and also tag the 17 by 17 Instagram account, which is on the QR code right there. And you can follow us and follow the journey because it will be a long one. I turned 17 this June, but we are extending the project for future generations that are going to be turning 17 in a year. So stay tuned, and I hope to see you all following the Instagram. Thank you.
Okay, we're about ready to start doing presentations stuff again. We have about 10 minutes. So someone came to me and said, you know what? We should try that anthem again. But this time, to those who go, we are, there's prizes. On va faire encore le thème. Puis lorsqu'on va chanter we are, on a des prix. You guys want to do it? Voulez-vous participer? Oui? All right. So, okay. So, I'm just going to ask Neil, can we put the theme again, the song? Can we put the anthem again with the words? Just getting the crowd to sing again. Yeah, the song up, yeah. Okay. Okay, here we go.
From every coastline, every city, every school, new waves rising. Yeah, we're breaking all the rules, they see the problems. We just see the work to do, a different vision. Shining, brilliant, shining blue. We are the innovators, we are the engineers. We're the scientists, silencing all the fears. We see the UN decade, we know the time is now. They ask who's gonna fix this, we're here to show them how it's more than just a project.
It's coming.
It's more than just
and I want to hear it loud. We are. Okay, wow. I'm going to need some help here with the prizes. That's a big table.
Architects, the engineers, the truth. From a single ripple to a tidal wave, you're gonna hear the sound we've made.
Okay, this is the last one, so let's make sure it's the loudest one, all right?
The future of the ocean is right here and right now.
That's right!
Patrick, you might not have heard, but I was singing as well. I want to have some questions.
Marc-André, tu chantes-tu chez toi aussi?
Bah oui, on chante. We are Generation Blue.
Wow. Great job, everybody. That was super awesome. Good job. Wow. Okay, so let's go on with the presentations. On va continuer avec les présentations. Marc-André, t'es là? Marc-André?
Ben oui, je suis là.
OK.
We are there.
You are there.
On est là.
You are? OK. All right.
C'est ça. I am.
Alors, notre première équipe, c'est Marine Muses. Our first team is Marine Muses. So I'll invite them to the stage to do their presentation. Did you have a good lunch, Marc-André?
An awesome lunch. My daughter came in, and we had a good sandwich. There was no seafood in there, though.
Oh, I had a sandwich with tuna in it, so I stayed on topic. Oh, whenever you're ready, come on the stage. Okay, so Marine Muses are ready.
Hi guys, we are the Marine Muses. My name is Lisbeth.
I'm Livia.
I'm Ada.
I'm Ria.
And I'm Parmida. And without a further ado, let us dive into our idea, Smart Salmon. Today we will be discussing the importance of Atlantic salmon, the challenges they face, and many of the finer details of our product. Atlantic salmon are often briefly mentioned and overlooked, but in reality, they have a much greater impact than most know. Firstly, they provide sustenance for millions around the globe, playing an invaluable role in the lives of not just Canadians, but also communities across Europe and North America that rely on them for food, livelihood, and culture. Additionally, Atlantic salmon act as an alarm for changing environmental conditions due to their strict requirements for water quality, fluctuations in their populations, or unusual behaviors are often signs of greater environmental issues. Speaking of impact on ecosystems, Atlantic salmon are also keystone species, supporting the growth of countless other species like freshwater pearl mussels, otters, and even bears. However, Atlantic salmon are now facing an unprecedented threat. Due to climate change, Atlantic salmon populations are rapidly declining, unable to tolerate these new varying conditions. Additionally, salmon are discovering uncomfortably warm waters and in some cases, blocked or altered river flow. Fluctuations in river flow are particularly concerning as they prevent salmon from returning to their spawning grounds. Furthermore, shifts in key water conditions like oxygen, temperature, and pH happen quickly, increasing the difficulty for salmon to adapt. We can't forget about our own East Coast, however, where storied salmon rivers like the Miramichi are seeing 20,000 salmon return as opposed to the previous 120,000. As a result, vital changes in salmon habitats have often gone unnoticed until shockingly low numbers of returning fish have called us to action.
However, hope isn't lost just yet. Across the world, governments, fisheries, and dedicated conservation organizations are working to promote rises in salmon populations. A particular way that this is achieved is by raising awareness. This is particularly achieved through organizations like the Atlantic Salmon Trust and the Atlantic Salmon Foundation. For instance, they create web pages and post on social media accounts about the plight of this vital species, encouraging audiences across the globe to take action. Furthermore, these organizations often offer workshops and programs, reaching broader audiences and educating them about the importance of salmon in our ecosystems. Next, countless governments all over the globe have also created laws and policies that help promote the conservation of salmon. For instance, the Government of Canada has recently released its National Atlantic Salmon Strategy, which details its plans and efforts to protect this vital species. For instance, the strategy places particular emphasis on salmon farms and hatcheries, as well as promoting international conservation efforts. Now, about the final measure, salmon farms and hatcheries. Across the globe, these establishments work to grow and release salmon into the wild, hoping to boost their populations. However, experts have recently raised concerns that these released salmons are often disease-ridden, weaker, or simply different than wild populations, leading to detrimental effects. As a result, it came to our attention that there was an urgent need for an affordable, reliable water quality monitoring system for farms and hatcheries of all sizes. Which brings us to our solution, Smart Salmon. Our solution is a sensor-based system that collects data on various factors, including pH, turbidity, and total dissolved solids, and relays real-time data back to the user. Also, this will help highlight previously missed fluctuations. Now, let's get into how our product works. As mentioned before, we have sensors for turbidity, total dissolved solids, temperature, and pH. These sensors collect data and relay it back to the microcontroller, which in our case is a microbit attached to the B-board. This data is then stored where it can be analyzed by the user. As for our system setup, the device is secured at a fixed depth in an enclosure. For us, in terms of our testing, this was a depth of approximately 2 meters. This will allow salmon farms and hatcheries to collect real-time data and ensure that their released salmon are stronger and healthier than ever. Finally, I'd like to touch on the future research applications of this data. By analyzing and organizing this data, we can also see how fluctuations in these factors are affecting salmon growth.
Now, let us break down the materials behind our design. At the core of our system, we used a microbit which stores and runs our code, and this connects to the B-board, which acts as the main interface for all components. A battery pack provides power to the entire system. Next, we have our sensors, which measure key water conditions: turbidity, temperature, pH, and total dissolved solids. These sensors are connected to the B-board using jumper wires and interface modules, allowing data to be transmitted and processed in real time. For physical design, we used a waterproof plastic enclosure to protect the electronics. We sealed openings using marine-grade caulking and secured components with adhesive materials to prevent movement. Finally, we used a line and a carabiner to anchor the system in place during testing, ensuring it remains stable in the water. Now, to put everything together, this is our fully assembled prototype. As you can see, all components are housed inside the enclosure with sensors extending outward to collect data directly from the water. The system is designed to remain stable and protected while continuously collecting data in real-world conditions. We tested this prototype in 2 locations, Tin Can Beach and St. John River, allowing us to evaluate both performance and reliability in different environments.
This slide shows the data we collected during testing at Tin Can Beach and St. John River. Overall, our system was able to successfully collect real-time data from different factors for multiple parameters, including temperature, pH, turbidity, and TDS. At these 2 graphs, you can see the average data at both locations. We can see a drastic difference, which might be caused because the first testing wasn't fully accurate, as our prototype wasn't in a water that was deep enough for the sensors. Looking at the graphs, most values such as pH, TDS, and turbidity remain relatively stable, which suggests that water conditions were generally consistent during testing. However, we did observe some irregular readings. For example, the pH sensor occasionally produced values outside of the normal range of 1 to 14. When this happened, we removed the sensor and recalibrated it until it returned to accurate readings. You're not able to actually see these in there because we deleted them, except for the one line in there, which you can see it went up to more than 20, which is not within the normal range. And that was the indicator that it was not working properly and we had to recalibrate it. We also noticed that the temperature repeatedly jumped between about 5 degrees to 25 degrees, which you can see really well in the graph. There was not an actual change of temperature. Instead, it was caused by the loss of connection, power issues, or possible water entering the enclosure. The 25 degrees is the default temperature that is used for the other sensors to work. That's why it went to 25. We identified this as a system error because the readings switched consistently between two fixed values rather than changing gradually as a real-life temperature does. To address this, we dried the enclosure, adjusted connections, and replaced the batteries to stabilize the system. Despite these challenges, the system was still able to continuously monitor water conditions and detect irregularities. These results helped us identify important improvements, such as better waterproofing, more stable connections, and reliable power supply.
Now, I'm going to talk about how our business strategy and where Smart Salmon is headed. First, our target audience. We are not trying to compete with large industries like YSI or Campbell Scientific. Instead, we're focused on groups that actually need affordable solutions, like conservation organizations, First Nation communities, schools, and smaller hatcheries with limited funding. In New Brunswick, that includes groups like the Atlantic Salmon Federation, Fundy Salmon Recovery, and communities like the Wolastoqey Nation and First Foley Nations. It also includes programs such as Fish Friends, which reaches over 60 schools. Next, our marketing approach. We mainly use social media, especially Instagram, for our updates. We post updates on our prototypes, testing videos, and even some fun content to keep our viewers engaged. It's a simple way to build awareness and show what we're actually doing. We also promote it through our own personal accounts and plan to do workshops in schools. So this is our page, and follow it. And this is one of our videos that we did post on. Okay, next. Finally, our pricing. We plan to sell Smart Salmon for around $800 per unit. That's much cheaper than most existing solutions, which can cost thousands of dollars. We also plan to make about $350 to about $450 per unit. And we also plan to offer a $10 per month subscription for data monitoring. Our future. Looking ahead, we have a clear plan on how to grow Smart Salmon. First is research. We're continuing to study what conditions are most important for salmon, using sources like Fisheries and Oceans Canada and feedback from our advisors. Second is development. Our next step is adding a dissolved oxygen sensor, which we're currently working on. We also want to make the system wireless, build an online database for storing data, and create a website with instructions so other people can use it too. Finally, expansion. Our system works well for Atlantic salmon. We want to adapt it for other species like Pacific salmon, trout, and Arctic cod. Over time, this could become a great water monitoring system used in different environments. Long term, our goal is to share this globally because our design is open source and it can be used by conservation groups anytime and anywhere. Our vision is simple, starting here in New Brunswick, but eventually helping protect salmon populations around the world. The problem is clear, the gap exists, and Smart Salmon is our solution. Thank you. Follow us on Insta. Any questions? Thank you.
So that's definitely an interesting risk or challenge that we're looking forward to. And we will definitely be working to improve our prototype to account for these risks in the future. But yeah, thank you for your question. Is there anything else? No? All right, well, thank you very much for your time and attention. Oh, my bad.
Okay. Thank you, Marie Muse. I got some of your notes right here. I could work on your project too. I'll just leave those here, okay? Okay. All right, so just to catch up on the time here, we're going to get the Crusaders of the Wave to come to the stage and do their presentation. Marc-André, what did you think about the Marine Muses?
It was awesome. My wife comes from Miramichi, and there's a, like they said, there's a salmon hatchery not too far from there. So it actually reached straight to my heart.
Perfect. Okay, so I believe the Crusaders of the Waves are ready. Are you guys ready? Oh, okay. One finger. All right, so they told me to wait one finger, so I'll wait one finger. So while I do that, do you guys want to have a trivia question? Yes, Patrick, we want a trivia question. Okay, I'm glad you asked. Okay. All right, so the question, phytoplankton are responsible for producing what percentage of the world's oxygen? Shout percentages to me, please. 50. We right on the money. It's between 50 and 80%. Good job. All right. Now, are we ready, Crusaders of the Wave? Okay, come on stage.
Hello everyone, we are the Crusaders of the Waves, and our project is called the Hydro Guard. And here's a small intro video in our hometown in Newfoundland. Okay, some technical difficulties. But hi, I'm Alexis Tavener, and I'm Research and Artistic Design Lead.
Hi, I'm Isaiah Tall-Hancock. I'm the business lead. I manage the budget, outreach, and planning.
Hi, I'm Isaac Turner. I'm the engineering lead, and I designed and built the prototype.
Atlantic salmon face many challenges, including rising water temperatures, pollution, habitat disruption, and climate change. Monitoring these conditions is often expensive, inconsistent, and difficult for small communities and schools. There is a need for an affordable, continuous, and easy-to-use monitoring system.
We are designing an aquatic monitoring device. It collects real-time water data. It is affordable and easy to deploy. It can be used by schools, researchers, and conservation groups. It helps protect salmon eggs. This device includes a temperature sensor, a pH sensor, a turbidity sensor, and a water flow or current sensor. It can log data and may include wireless transmission in the future. It also uses an artificial red to attract salmon and protect the salmon's eggs.
At our school, we are currently raising Atlantic salmon from fish-eyed eggs to fry. In May, we plan to release them back into their natural habitat in the Exploits River for conservation efforts. We did this through partnership with FABEC, which stands for Freshwater Alexander Bay Ecosystem Corporation, and ASF, which stands for Atlantic Salmon Federation.
In this image, I am testing the pH and the ammonia of our fish tank's water.
And in this picture over there, I'm checking the temperature of the water, which would normally take 2 minutes, but with our project, it takes seconds.
Salmons create reds, which are nests made in the riverbed. A red is made up of a pit, which is a mound of gravel downstream. Reds are built in flowering water with good gravel, usually in depths of 15 to 75 centimeters. They protect the eggs from predators and help keep them cool and oxygenated. Reds are very fragile. Walking on them can crush the eggs, so it is important for anglers to avoid these areas. So these pictures here, in that first one, there's an alvin and a salmon egg, and then this second picture over here is an alvin, and under it you can see it's called a yolk sac, which feeds them until they turn into fries, and then we have to feed them around 3 times a day.
Atlantic salmon are declining in Newfoundland and Labrador due to environmental change and habitat damage. Our project, the HydroGuard, is a low-cost system that monitors water conditions like temperature, pH, turbidity, and current speed. It helps identify threats early, supports conservation efforts, and can be adapted for other aquatic ecosystems.
And this is us meeting with Mr. Sean Jackson from Faybeck. And there's another meeting with Sean Jackson. And that's the salmon tank at our school.
So materials needed, sensors like temperature sensors, pH, turbidity sensors, microcontroller bringing the Brilliant Lab B board, and microbits, waterproof casing so it doesn't mess up any wires, get it wet and it breaks. Power supply, battery packs to keep it charged without needing outlets. Plants and rocks so they have places to hide and it's like their natural habitat like it would be if it was real. And then epoxy to keep everything together because that's a really hard thing that like keeps everything. It's like Gorilla Glue basically. It keeps everything together. Artificial eggs and fish for display to see what it would look like if it was real. So in these pictures here, this picture up there is our finished B-board with a turbidity sensor, and here's a light strip because the light strip has bright green LED lights and that attracts salmon to the nest. And over here we have a DS temperature sensor, which is waterproof that you put in the water and it tells you the temperature. Here with the computer there, that's when we're finishing up the code. And over there is our first prototype with the first code finished, which was the lights. Here's our code. These two up here, these two long ones, the first one there is showing the code to turn the LEDs on. The second one over here is to turn them off. And these on logo press long, on logo pressed, that brings up the Secchi disc, which is connected to the turbidity sensor, and that brings it down. And over here is the temperature sensor. This is the salmon red. That's our salmon artificial red over there. Inside, you can see it has artificial eggs to show what the real eggs would be like. And over here, we have a camouflage container for the Brilliant Labs B-board. And here, you can see the LEDs going around the bowl and the temperature sensor going inside of there. And the Secchi disc and the turbidity sensor is off to the side there. And we have a video now.
I really hope this video works.
We are the Crusaders of the Waves, and this is the HydroGuard.
So what the HydroGuard is, it's a dome, right? And inside is artificial salmon eggs, which represent what the real thing would be. So the salmon come to this hole here and lay their eggs and make the nest with their tail, as seen here, made with these rocks. And the salmon will come and swim out through here. Right here, surrounding it, is a LED light strip that shines bright green lights, because we researched a lot and that's what we found out that they like. So over here, we have the Brilliant Labs V board with a micro board here. So if we press the A button like that, shines red, and it'll turn on here, goes all around the bowl. And if you press the B button, it'll turn off. So next, we have the micro board attached with some wires, and it's attached to a water temperature sensor probe. So press the A button here. 21 degrees Celsius. So that's the temperature of the water. So next here, I'm gonna open it up. We got a DC motor that has a Suki disc attached to it, which senses the turbidity and how opaque or clear the water is. So if we hold down on the logo of the microbit, it'll go down, and then we press just once like that. We're gonna bring it back up. And that's the hydro.
Our product could be used by environmental organizations, fisheries and ocean groups, schools and education programs, indigenous communities involved in conservation, research institutions, and nonprofits focused on marine protection. What makes our project unique? As a low-cost alternative to expensive monitoring systems, which is less than $300. Student-built and education-focused, portable and scalable for different environments, and real-world impact on conservation efforts.
We will promote our project through school and community presentations, science fair and competitions, social media, and collaborations with local environmental groups. This picture shows some kids at our school monitoring our salmon for us.
So here's the financial plan. So the startup cost, sensors being around $100 to $300, microcontrollers like the Brilliant Lab B-board being from $50 to $100, materials and casing $50 to $100, and then miscellaneous items we may need during the process around $50, depends on what we get. And so the estimated total for this is $250 to $600. And our future funding options would be sponsorships, grants, and partnerships with environmental organizations.
Environmental impact supports salmon population recoveries, provides valuable environmental data, and promotes conservation awareness from salmon and other species. Educational impact encourages hands-on STEM learning, real-world problem solving, and student engagement in sustainability. We will add wireless data transmissions, develop a mobile app or dashboard, expand monitoring to lakes, oceans, and other species, and partner with conservation agencies.
In conclusion, this project combines environmental science, technology, and education to solve a real-world problem affecting aquatic ecosystems.
We are creating an affordable monitoring system that tracks water conditions like temperature, pH, turbidity, and current speed to help protect and restore Atlantic salmon by identifying threats early.
The goal is to support conservation efforts, raise awareness of ecosystem health, and inspire future environmental innovation. It was nice to see another team with a similar project as us, and hopefully we could collaborate and help save oceans and other species. Thank you.
And these are some of our references. Thank you.
Is usually caused by activities on land, like litter and debris. It also from runoffs like river and agricultural sites. It can also happen when come from boats, aka buoys, ropes, nets. So the North Atlantic Garbage Patch is a collection of garbage located between North America and Africa. It is a high concentration soup of plastics. It consists of it's very dense, has more than 1,000 pieces of garbage per square kilometer. It's created by ocean currents, aka the gyres. The North Atlantic Gyre is a clockwise rotating current in the North Atlantic Ocean. It's like a drain without the actual drain part. There are 5 gyres in the world, and each one has created a garbage patch. Our coastal pollution from us will likely end up at the North Atlantic Gyre, where the North Atlantic garbage patch is, if it's polluted. The role of water in Indigenous communities is water is thought of as a sacred living identity. It's called the lifeblood of Mother Earth. The two-eyed seeing approach is a way of thinking that combines Indigenous ways of knowing and Western scientific thinking. This is someone we met with named Ashley Sanipas. She said, when you gain knowledge, it is yours forever. She is a Mi'kmaq woman from Lenui, Metlege. She said water is life, and that pollution is affecting Indigenous communities because the environment is a way of life for them. She also said, rather than just educate them, you also have to engage them by building connections with Mother Earth. Towards reconciliation are 10 calls to action made by Indigenous scientists working in Canada. I will be reading the ones that we did. So the first one is to understand the socio-political landscape around research sites, to seek meaningful relationships and possible collaboration with Indigenous people for better outcomes for all involved. 5 is to provide meaningful opportunities for Indigenous youth to experience and participate in science. 6 is to incorporate place names as permitted, and 7 is to take a course on Indigenous history and rights. I can't do 8 and 9 because we didn't do them. 10 is, and they don't affect us, and 10 is to develop a new vision for conducting natural science, fundamentally mainstreaming the reconciliation in all aspects of the scientific endeavor.
Our problem is that the ocean is polluted with plastics that negatively impacts healthy marine life. What is the solution? There's multiple ways to attack this problem, although in the end, we chose to prevent garbage from going into the water in the first place. Our voices matter. Our project's objective is to advocate and empower youth to protect Nova Scotian coastlines through education and prevention. We have several goals, including educating students, motivating students, and organizing cleanup crews. Our hypotheses are that if we teach kids directly about ocean pollution, then they would be more motivated to helping us keep the oceans clean. Our second hypothesis is that if kids are more involved in cleaning local bodies of water, then we can help reduce the overall impact of garbage and plastic pollution. No one is too small to make a difference. A quote from Greta Thunberg. Greta Thunberg, an inspiration. Greta Thunberg is a 23-year-old Swedish climate activist proving to the world many things. This proves that you don't have to be an adult or make a new invention to make a huge difference. How does Brilliant Blue Cleanup Crew incorporate the UN Ocean Decade 7 outcomes? We tried to incorporate as many of the 7 outcomes as we could. We believe we succeeded in this field. Our collaboration with Scotian Shores. Scotian Shores is a Nova Scotian cleanup crew. In 2026, they picked up many things, including lobster bands, lobster traps, plastic straps, and pieces of agricultural gear. 80% of their cleanups are recycled. This is an image of us in a Zoom call with our mentor, Angela Riley. And this is an image with the team with Angela Riley doing a cleanup in Riverport. We collected over 700 pounds of garbage.
Our project. Our method. Firstly, to collect data. Groups of 2 collected garbage for 45 minutes, then waste was sorted and weighed. Secondly, surveys were conducted in participating schools. Surveys assessed knowledge about ocean pollution. Next, we created an awareness campaign featuring a YouTube channel and posters. Then we initiated a 4-week competition to get kids like us involved in cleaning up beaches and spreading awareness. This competition has 4 challenges, each related to the pollution. Finally, we re-administer surveys to establish the impact of our efforts. We will repeat this campaign and competition annually. These are the resources. Keep going. These are the resources used. As you can see, the resources here are very simple. We also tried to use as many reusable resources as possible, such as our gloves and feed bags. Our data. Here's where we organized our data. It's organized into type of garbage, location found, and amounts. We also measured weights, summarized here. We found that a higher amount of garbage could be found in more populated areas and that certain items were more concentrated together. We also found that if there was more traffic and less tourism, that there were heavier items. We sent out a survey that had 12 questions and 213 respondents. We asked about current knowledge and interest levels. Yes, go. Less than 10% of students felt they knew a lot about ocean pollution. While 79 wanted to learn more, 21% said they had no interest in learning about ocean pollution. Here's a graph of where we asked about the interest of students wanting to help with local cleanups. We found that 75% of students expressed interest in helping with coastal cleanups. Maybe we can find a way to motivate the other 25%. Here are the graph showing the interest in participating by school. As you can see, most of the students wanted to participate. Here's the questions based on general knowledge about ocean pollution. At least 50% of people know why pollution is bad, and 86% know that the most common trash in the ocean is plastic, but only 50% know that most ocean pollution comes from land. We asked questions related to the North Atlantic garbage patch and found that only 38% of students had never heard of the garbage patch. Our data shows we need to raise awareness and inspire people to want to help with coastal cleanups. Our next steps are to further analyze the patterns between the data. We need to re-administer the surveys. We need to finish this year's competition. We need to compare results. We need to expand to other schools, and we also picked up 1,600 pieces of trash off our beaches. We learned a lot. We had a very short timeline in this area at the beginning. Everyone has different timelines, and we needed to learn how to adjust, but overall, we learned how to work as a team and work together in the end better.
This concludes our presentation for today. We would like to give a big thanks to Miriam Kanakrian, Brilliant Blue, Blue Nose Academy, Scotian Shores, and Ashley Sanapass.
Alors, pour les francophones, ils ont à leur table ces petits cartons ici. Si vous leur envoyez un courriel, vous allez avoir la chance de gagner un chandail. Je vous encourage à aller les voir. C'est vraiment, là, ils sont parfaits. Ils étaient parfaits. OK. Marc-André.
Oui, monsieur, je t'entends finalement.
Ah, on s'ennuie de toi, là.
Yeah, the audio's back.
Okay.
So, funny story. Some years ago, Greta Thunberg actually came to Montreal, and I brought my 2 girls. One was about maybe 2 years old, something like that, and we decided to march with her. And I think we were somewhere between like 500,000 people over there, and there was a lot of people screaming and having fun. And my 2 girls, well, they slept the whole way.
Wow. Wow, that's a lot of people to go walk your dog. Wow. Okay. So, just to keep on time, actually, we're gonna welcome the other team, reaction team. I believe are they virtual or they're here? Reaction team. Oh, they're not here? Oh, okay.
The team, isn't it supposed to be Team Birchmount B?
Okay, well then we'll move on to Birchmount B then. So is Birchmount B ready to present? While they do that, per Jeff's request, I'm going to go for a dad joke. So, what do you call a fish with no eyes? Okay, yeah, okay, you guys are smart. Okay, all right. Hold your horses, I'll get a new one. Jeez. Why don't sharks eat clown? Because they taste funny. Oh, kill me now. All right. So, Birchmount B, ready? Yes? All right, so Birchmount B will come to the stage.
Hello. How's everyone? Are we good? Okay, that's good. So we are Birchmount B. I'm Aiden.
I'm Justin.
And I'm Leo. And our project's name is FAST, which stands for Fully Automated Sand Tester. What? So FAST is a crane/claw machine with pulley systems and wires and motors that it will use to go on a boat, collect sand using the motors. It'll go down to the ocean floor, collect sand, bring it up for lab testing. I'll pass it off to who's next.
So our team is Aiden, who is the team motivator and idea maker, Justin, which is me, the presentation director, and Leo, the main journalist, and Travis, who is not here right now, is the lead builder and coder.
And we also want to say thank you to Mario and the other person that we couldn't unfortunately remember the name of for helping us come up with this idea and design.
All right, so our mission is to protect the well-being of aquatic and underwater marine life, and also to keep the ocean healthy and, like, just generally safe so that, we can also be healthy, because if the ocean dies, we kind of die as well. Yeah, it's a big food source, and, anyways, I'm talking too much.
So our core values, I guess, we are honest, definitely. We're humble. Duct tape is one of our core values. Thing's awesome. And we also like making cool robots. So I guess that's really us as a collective group.
So the robot was initially conceived as a robot to remotely test water soil using a drill mechanism that allowed sensors to access the soil. The first design was neutrally buoyant and free-floating, so it could just float down to the sea floor and then deploy the drill to let the sensors access the soil to test it remotely rather than going into a lab. But we changed the concept due to it being too complicated for us to make it, and it was just required advanced coding skills and delicate components. The final design also has limitations. While the original drill included a detection system to avoid harming underwater organisms or rocks, the new claw design relies on gravity and cannot identify what it collects. Additionally, the initial concept required the entire machine to be waterproof, which would have been challenging for an inexperienced team. In contrast, the revised design keeps most mechanisms above water, simplifying construction.
Okay, so clearly this is an old part of the presentation that we accidentally turned in, but our customer needs are, well, I wouldn't say customer needs, I just say customers in general. It's affordable, anyone can use it since it's on a boat, so people who have large plots of land or lakes or any bodies of water can attach this onto any boat and it'll work almost automatically, and it's user-friendly, so it's really basic to use. It's press button, go down, press button, go up. So it's easy, simple to use, and it's a robot. Who wouldn't want a robot on your boat?
And that's the end of the presentation, even though there's supposed to be more. We just edited last second, but it didn't update here. So
thank you.
Do you have any questions? Okay.
Okay, thank you, Birchmount B. All right, so now since reaction team did not make it, our break is going to be a little longer. So what we're going to do first, because we've been sitting down for a while, we're going to do some exercise. So everybody get up. Everybody get up. Everybody get up. I see people sitting. The people that's sitting, I'm going to go get you up. Come on. Let's get up. Okay. So we're going to put our hands like this. I do this. Flex your knees. Snappy, snappy, and we're a crab. I can't believe I got you guys to do that. All right. So, good job, Marc-André. I think I hurt myself, though. All right. So the next team that we'll be presenting will be Grammar Griffins, but that's going to be around 2:30. So we have a little break. You can go to the photo booth. Go see that booth in the back there, that section in the back, to get your chance to win a T-shirt. I believe there's still jet boats to go. So what we're going to do is once we're going to be close to 2:30, we'll play the anthem again. We are, right? So we're going to play that theme, forget everybody back in here, and continue with the presentations. OK? Alors, on va continuer à faire la présentation à 2h30. Alors, à 2h30, un petit peu avant 2h30, on va jouer le thème. avec la chanson We Are, We Are. Et en attendant, vous allez prendre des photos dans le kiosque de photos qui s'est installé à l'extérieur près du lobby ou encore les bateaux. D'accord? On se voit tantôt.
We're just give us 1 minute, 2 minutes. Give us a second.
Are you grabbing her?
Yes.
Okay. So this works. I can give you a second. I can still talk while you guys are no problem. Oh yeah. Okay. I just want to get the people back in here. All right, so if the people outside in the lobby hear my wonderful voice, we're about to start in about 2 minutes. Si les gens qui sont dans la réception entendent ma voix, on va recommencer dans 2 minutes. On voit déjà que Grammar Griffins sont prêts à présenter. We see that Grammar Griffins are eager to present. So if we can get everybody back in the room, that would be awesome. Okay, Marc-André, are you there?
Oh oui, je suis là.
Okay, parfait. All right, so all the co-hosts are here. The team is here on the stage. And, well, Grammar Griffins, take it away.
Hello, everyone. We are students from the Halifax Grammar School. We are the Grammar Griffins. My name is Srinath. This is Alyssa, Lena, and Jay. The ocean is often described as vast, powerful, and mysterious, yet it needs protecting. Across the world, oxygen levels in the ocean are dropping, creating what scientists call hypoxic zones. And the most alarming part, these zones can form before anyone even realizes they're there. Fish don't migrate in time. Ecosystems collapse without warning. And by the time we detect the problem, the damage is already done. So we asked ourselves, what if we didn't have to wait? What if, instead of reacting to hypoxia, we could predict it? What if the ocean could signal to us before it's too late?
Every good project begins with an idea and an objective. Our objective is to detect hypoxia zones, low oxygen areas in water using a hydrophone. Thank you. If fish exhibit avoidance behavior in response to declining dissolved oxygen, then variations in underwater acoustic signatures are expected to correlate with oxygen concentrations because fish either emigrate from hypoxic zones or experience mortality under severe oxygen depletion. Hypoxia zones are typically defined as aquatic regions, marine or freshwater, in which dissolved oxygen concentrations fall below the critical threshold, resulting in markedly reduced oxygen availability. As a result, most aquatic organisms cannot persist under these conditions and either experience mortality or migrate to more oxygenated habitats. Such shifts can disrupt ecosystem structure and function, posing serious ecological challenges, particularly in marine environments. In 2023, researchers deployed a benthic instrument pod into the Bedford Basin. The study area, a seasonally hypoxic zone, experiences recurring low oxygen conditions. A submerged sill limits water exchange to the upper 20 meters, promoting stratification that isolates deeper waters. This zone typically begins in late summer and ends in late winter. We plan to test our robot in the basin during the hypoxia and after to compare sound and oxygen levels.
So last year, we met with Bryce McGinnis, the data and AI algorithms lead at DeepSense. He proposed using audio analysis techniques to monitor fish vocalizations. Additionally, Bryce suggested implementing oxygen level forecasting using time series analysis to predict potential hypoxia events in advance. We also met with Josh Tabor, who helped us take another big leap forward. He taught us what a National Instruments DAQ is, and he also suggested using an IMU. This helps stabilize orientation, remove motion noise from acoustic data, and detect current-induced movement. He also suggested we use a waterproof housing from Blue Robotics because it makes sense for electronics enclosure, hydrophone preamp, DAQ interface, and it's rated for depth pressure. They also built us a custom AI application software to implement our data and convert it into spectrograms. The AI will then detect abnormalities in the data. Hypoxia also has a direct impact on fish. It can cause stress on enzyme activities, progressive cardiac tissue, and increased gene activation. Our solution is designed to protect marine ecosystems and wildlife by preventing their environments from becoming hypoxia zones. By detecting when these low oxygen areas are forming, we work proactively to halt their development before they occur. This vital intervention helps keep the ocean alive, ensuring the health of the marine habitats and the diverse species that overcome them.
Now we move on to the robot design and engineering. This is the evolution of our prototype. When we first started this project, we started on the picture on the far left, which is the underwater drone. It has 4 propellers to move it underwater freely. There's a hydrophone dangling in the back and an oxygen sensor in the front. But after consideration, this model is too complex for our project. Then we decided to move on to the tube on the right of it, which is called a buoyancy glider. There's a hydrophone put inside the tube, and the rest dangles out so that sound data can be collected. This was the design for the FL competition. But later, when we want to further test it, we found out that it's too complex for project still. This buoyancy glider needs a high level of precision in engineering and programming. So after numerous visits, such as geospectrum visit, cold visit, and Dalhousie oceanography visits, we settle our design into our ROV, which you guys can see here. This is our design process. We started by brainstorming in our group. These are the 3 drawings we came up with. They have their own advantages and disadvantages. We combine all the advantages from these 3 drawings, and we combine them into a 3D model, which you guys can see on the right. We designed this in consideration of flotation, balance, compatibility with auxiliary sensors, such as hydrophone and oxygen sensor, and also structural rigidity, so it doesn't fall apart underwater. How we build it. We assemble the PVC pipes first according to the 3D design. Then the control unit was soldered so that 3 buttons can control the 3 motors. After the control unit was built and troubleshooted, we connect the motors to the controller. These are the components. So the one with the 3 buttons, that's the controller. If we toggle the button, you can move the motors front and back. The motor in the middle is the motor that controls the dive and the going up. The 2 motors on the side, they can propel the ROV forward, backwards, and turn the ROV.
So next we have our project IBR, or it is the Integrated Buoy or ROV system. This is a dual system or platform ocean monitoring system consisting of an autonomous submersible and a stationary buoy. Our objective is to provide real-time detection and predictive modeling of hypoxia or low oxygen zones in Atlantic Canada's coastal waters. We achieve this by integrating high-precision oxygen sensors with AI-driven hydrophone analysis. This diagram shows our BIR data lifecycle from raw data to final insight. It begins with data collection, where underwater acoustic and sensor data is gathered directly from the environment. This is followed by local transmission, where the data is sent from the underwater system to a surface relay for further handling. Next, we have processing and analysis, where our system filters and interprets the data to identify patterns and possible signs of hypoxia. This step is crucial for turning raw signals into information.
Our next step is testing our ROV system to evaluate how it performs outside of our development stage. We'll begin with the control environment, such as a pool or a testing tank, to check stability, functionality, and data accuracy under predictable conditions. This allows us to identify and correct any issues early. After that, we'll move to open water testing, such as Point Pleasant Park, to evaluate the performance under real ocean variables like currents, noise, and challenging conditions. Based on both stages, we'll make revisions to improve durability, reliability, and sensor integration. These are the sensors we're going to use. The first one is called the hydrophone. It can collect sound data from underwater. And the one on the right is the oxygen sensor. It can detect the oxygen level of the water area that we're testing. This will significantly improve the ability to detect early environmental changes.
So another branch of our team is the media committee, with our first role being documentation and organization. At every weekly meeting, we document the progress that the team has made, especially in robot building and also data and research. We then organize these photos, videos, and documents that we have taken into an organized Google folder to keep track of what we have done in the past and make better plans for the future. Additionally, we manage our Robotics Club website, which contains information about who we are, what we do, what hypoxia zones exactly are, etc. Our second role is outreach and communication. Over the past, we have reached out to various organizations and experts, as mentioned before, for help and guidance. For example, Bryce McGinnis, Levi Morrison, and the Geospectrum organization. This outside assistance has allowed us to further widen our horizons and better develop our skills in terms of building and constructing a truly impactful robot. Lastly, we are preparing for potential fundraising events in order to further gain support for this club in terms of financial aspects, as there are still more steps in the future for us to complete, like obtaining a full waterproof robot, purchasing an optical oxygen sensor, etc., which all require money.
Our journey began with the first LEGO League, where we first developed our initial prototype. That experience pushed us to think critically, not just about building a solution, but about solving a real-world problem with impact. Through FLL, we advanced to the international level, where we competed at the Worcester Polytechnic Institute of Technology against some of the top teams from around the world. It is there where we achieved second place. We then took valuable feedback and refined our design and expanded our research. This led us to compete in the Brilliant Blue competition, where we applied everything we had learned and ultimately win at the national level. But more importantly, each stage of this journey shaped how we think as innovators. It taught us about using critical thinking and adapting to outside the box outside the box thinking. That mindset is what brought us here today. Looking ahead, our goal is to scale our prototype into a real-world ocean monitoring system with practical impact. A major step in this process is a collaboration with Geospectrum Technologies, where we aim to use their advanced underwater acoustic software to improve the accuracy of our detection systems. Our next technical milestone is Phase 2 integration of low-ray WAN technology. This will allow long-range, low-power communication between our underwater glider and a surface buoy, which will act as a gateway, sending real-time environmental irregularity reports to shoreside labs. We are also continuing to refine our acoustic filters to better detect changes in ecosystem health and translate underwater data into meaningful insights. Beyond development, we are committed to an open science approach. We plan to present our work at the Halifax Open Tech Expo and build partnerships with organizations like COVE and the Ecology Action Centre / Fisheries in Ocean Canada to help bring these systems into real-world use. On this slide, we have all the sources we have used for our information, but the majority of our info came from all the various companies, researchers, and environmental experts that we have contacted and visited. So this journey, from early prototypes to international competition and expert collaboration, has transformed our project. We are now developing an advanced system that combines autonomous robotics, underwater acoustic sensing, and real-world oceanographic data to detect hypoxia zones earlier and more accurately than ever before, in a way that is innovative, scalable, and grounded in science. We are excited to keep pushing forward, not just to compete, but to make a real impact in how we understand and protect our oceans. Thank you for listening.
All right. Thank you, Grammar Griffins. All right. So, next team up, Équipe L'Héritage. Are they here? L'équipe Héritage. Oui, ils sont là? OK, parfait. All right. So, just to mention, we do have a timer on the corner of the stage. You have 10 minutes. When you see me get up, you have about 1 minute left of the presentation, OK? I forgot to mention that at the beginning of the day. So I make mistakes too. So I'm human. OK, Marc-André, es-tu là?
Oui, je suis ici.
OK, parfait. Alors, as-tu un trivia à causer à la salle?
Hey, oui, j'en aurais une. Rapidement, combien de pourcentage de l'océan reste inexploré?
Okay, what's the percentage of the ocean that's unexplored right now? Jeff said 99.
I got 80%.
80%? Oh, Jeff wasn't that far, actually. OK. École L'Héritage, êtes-vous prêts? Oui, parfait. Alors, c'est à vous.
Merci.
Celui-ci fonctionne.
J'ai pas le clicker. There we go. Anyways. Okay. Okay. Bonjour à tous, nous faisons partie de l'équipe Héritage secondaire public originaire de Cornwall, Ontario. Et je m'appelle Stéphanie.
Firas.
Et moi, c'est Ryan.
Aujourd'hui, nous allons vous présenter notre projet écologique, les microplastiques en lieu aquatique. OK. Mais avant de commencer, une question. Savez-vous quelle est la plus grande source de microplastiques? Non. Oui, bravo. C'est vrai, ce sont les textiles synthétiques. De nos jours, l'équilibre des écosystèmes aquatiques fait face à un défi invisible, mais dévastateur, la pollution par les microplastiques. Bien que plusieurs systèmes de nettoyage existent déjà, nous avons conclu que l'approche la plus efficace réside dans la réduction à la source. Nos recherches ont démontré que le lavage domestique constitue l'une des principales sources de propagation de particules polluantes, rejetant des milliers de fibres synthétiques directement dans nos réseaux. Cet enjeu est particulièrement préoccupant pour le fleuve Saint-Laurent, un pilier important pour notre biodiversité régionale. Donc, nous avons entrepris de concevoir une solution technique et durable visant à intercepter les particules à la source.
Nous sommes passés par différents types de prototypes. En premier, nous avons trouvé ce prototype en ligne et on s'est dit que ce sera un de nos exemples. Après, nous avons fait un en Lego et après, nous avons acheté un pour tester son efficacité et nous avons fait notre propre prototype sur Thinkercard et nous l'avons imprimé juste ici. C'est sûrement pas le dernier qu'on fera. On fera bien d'autres prototypes, mais pour l'instant, c'est lui.
OK, alors...
Pour faire notre prototype, nous avons eu besoin de contacts. Nous avons contacté des organisations à but non lucratif comme l'Action Babochette, des usines comme Fab Lab et Antec Madison Plastic Corporation qui pourront nous aider pour l'industrialisation. Nous avons eu aussi besoin d'aide d'experts comme Madame Christina Charette, un institut du fleuve, et Monsieur Dr Zilou, qui nous a aidés pour les ressources.
OK, alors je vais expliquer un peu plus qu'est-ce que nous avons fait pour notre projet. Alors, nous avons commencé par collecter de l'eau du fleuve Saint-Laurent pour nous donner un peu une base de ce que l'eau les microplastiques dans l'eau est. Après ça, nous avons utilisé une machine à laver de notre école pour vraiment tester s'il y a actuellement des microplastiques qui se produisent dans la machine à laver. Alors, qu'est-ce que nous avons fait? Nous avons pris 2 samples de l'eau d'une machine à laver, un qu'on a filtré avec notre filtre prototype et un qui n'était pas filtré. Et après aussi, nous avons pris l'eau du fleuve Saint-Laurent qui était non filtrée. Ce que nous avons fait, nous avons actuellement allé au collège Saint-Laurent, qui est le collège très à côté de nous, pour vraiment tester et analyser les résultats. Ce que nous avons trouvé est que l'eau est moins contaminée, comme l'eau qui était filtrée était moins contaminée que l'eau qui n'était pas filtrée. Alors, notre machine filtre à laver a fonctionné.
Nos objectifs. En premier, nous voulons protéger la vie marine contre la pollution.
Éliminer cette pollution à la source, c'est-à-dire pas chasser un problème continuel, mais l'éliminer à la source.
Et favoriser la santé et le bien-être mondial. Alors, notre public cible pour notre idée, on va commencer avec un endroit local comme l'Ottawa.
Et après, nous attaquerons à la provinciale, c'est-à-dire nous allons vendre notre produit au Québec et autres provinces.
Suivi par un niveau national aussi au Canada.
Et finalement, nous voulons être une compagnie mondiale, puisque avec le mondial, le plus de microplastiques vont être arrêtés avec ces types de filtres.
OK. Pourquoi nous? En premier lieu, le prix de notre filtre sera abordable et compétitif pour que nous puissions se distinguer des autres compagnies créant des filtres similaires aussi.
OK. Nous voulons aussi fabriquer les filtres de matières recyclables. Alors, ceci dit, comme on va éliminer la pollution de l'eau avec les microplastiques, mais aussi la pollution de plastique en général.
Notre projet sert aussi comme sensibilisation d'un enjeu écologique majeur, même s'il ne peut être observé de vue microscopique. Par exemple, on veut que tout le monde sache c'est quoi un filtre pour les machines à laver.
OK. Suivant par la promotion. Au début, on va commencer par des ventes directes, c'est-à-dire comme des porte-à-porte. Nous allons aller sur le terrain des autres pour vulgariser l'utilité du produit et créer un lien de confiance immédiate avec les familles. Aussi, on va faire comme un contenu viral, c'est-à-dire comme des trends. On peut lancer un mouvement sur les réseaux sociaux avec le hashtag #MonTonFiltre pour rendre le produit cool aux yeux des jeunes.
On peut aussi faire des concours impliquant la communauté en faisant des concours pour faire connaître notre marque davantage au public cible.
Et mon idée préférée est d'avoir des ambassadeurs techniques. Alors, au lieu d'être nous qui installent les filtres, c'est les plombiers et les mécaniciens qui actuellement fonctionnent sur les machines à laver pour vraiment faciliter la simplicité pour les gens, les consommateurs du produit.
OK. Et où vendre? On va commencer de vendre et commercialiser notre projet localement, c'est-à-dire à Ottawa ou Cornwall où on vit. Ensuite, on peut aussi vendre notre filtre en ligne pour qu'il puisse être accessible à tout le monde au cours des années et aussi à grande échelle avec la distribution aux compagnies mondiales.
Nos prochaines étapes. En premier, nous voulons perfectionner notre prototype pour assurer le fonctionnement adéquat et réaliste. Nous voulons aussi intégrer une application qui permet de recevoir des notifications quand votre filtre est bloqué ou saturé.
Rempli, oui.
On veut concevoir un deuxième filtre qui capture les particules volatiles de la sécheuse, qui veut dire qu'on aussi élimine le plus de textiles et microplastiques possible.
Par rapport à l'application que je parlais, voici le QR code si vous voulez le scanner. L'application ressemble à peu près à ça pour l'instant. C'est aussi un type de prototypage. Quand vous rentrez dans l'application, ça vous permet de voir combien est la qualité de votre filtre, parler à une intelligence artificielle qui vous aidera comme conseiller et bien d'autres.
Si vous voulez actuellement le scanner, ça actuellement fonctionne et ça te donne un vrai site qu'on a essayé de créer nous-mêmes. Okay. Change de slide à 3, 2, 1.
OK. Et les prochaines étapes écologiques. On veut intégrer une loi comme celle en France, que Ferraz va expliquer plus tard, au Canada. Et on veut élargir et sensibiliser notre public cible en influençant la population davantage.
Nous voulons aussi élargir la sensibilisation de notre public cible parce que le plus de personnes qui connaissent dessus les microplastiques et connaissent ou qui ont aussi ce type de filtre, ça va aider le plus, arrêter le plus de microplastiques possible.
Nous voulons aussi réduire le nombre de déchets plastiques dans les océans, car en principe, nous voulons que notre prototype soit conçu à partir de déchets plastiques. Et aussi, nous voulons insérer les filtres directement dans les machines à laver, ça veut dire aux usines directement.
Ceci va aider avec la simplicité de notre prototype.
Par rapport à la loi AGEC, qui est en France, à compter du 1er janvier 2025, la loi française impose que tous les lave-linges neufs, domestiques ou professionnels soient équipés d'un filtre à microfibres plastiques. Cette mesure vise à limiter le rejet de microplastiques issus des textiles synthétiques dans les eaux usées qui finissent souvent dans les océans. Protéger notre héritage bleu. La plus grande menace pour notre écosystème n'est pas ce que nous pouvons voir, mais ce que nous laissons échapper. L'innovation commence à la maison.
Merci beaucoup, guys.
Merci.
Y a-t-il des questions? Oui, Monsieur Jeff? Alors, peux-tu expliquer? OK, alors, probablement notre plus grand défi est relié comme à notre équipe en général. Nous sommes des personnes qui ont beaucoup de choses extracurriculars qu'on fait à la maison et autres comme des sports, des autres clubs, comme le club environnement et le GDE. Mais je dirais que c'était aussi comme nos coéquipiers avaient besoin de quitter notre projet puisqu'il y avait trop de stress relié à ce projet. Alors, c'était triste, mais ça arrive avec des choses comme ça en général et autres compagnies en général aussi. Ça arrive et ça vraiment nous donne de l'expérience réelle à ce qui arrive dans une compagnie. Oh, ça c'est une bonne question, monsieur. OK, alors, nous voulons être réutilisables pour actuellement comme avoir le moins de gaspillage possible. Alors, notre prototype va être où tu peux enlever, c'est comme un vis, où tu l'enlèves. Après ça, tu enlèves ton filtre et tu juste tu le déplaces. Tu peux le réutiliser, alors tu jettes les microplastiques dans peut-être un contenant, quelque chose comme ça. Après, tu l'envoies au entrepôt de déchets quand tu as fini avec. Alors, de cette manière, tu peux l'utiliser, le filtre microplastique, pour plusieurs ans. Ça, c'est l'idée.
Yeah. Et aussi, on va utiliser des matières recyclées pour créer notre filtre. Fait que c'est comme un cercle. On ne va pas envoyer des microplastiques dans l'eau qu'on vient juste de comme récupérer. Fait que, yeah.
Autre question, guys? 3, 2, 1, sold. All right.
Merci.
Merci.
OK, merci beaucoup, l'équipe Héritage. On va voir l'équipe Maurice-Lapointe qui va se présenter et faire une présentation. Alors, Marc-André, est-ce que tu as aimé cette présentation?
J'ai pas compris. Comment?
Est-ce que tu as aimé la présentation de l'équipe Héritage?
C'était excellent.
Okay.
Moi, justement, je me disais, je pourrais installer ça sur ma laveuse. Ça serait de toute beauté.
Oui, non, c'est vrai, hein, ce serait avantageux. Écoute, Marc-André, j'ai une question pour toi.
Oui.
What is the name of the massive collection of floating plastic and debris located between Hawaii and California?
It would be the floating island.
The Great Pacific Garbage Patch. Oui, c'est ça. Bravo. 2 morceaux de robot pour toi, Marc-André. Good job. Anybody else knew that here in the room? Yeah, over there. Of course you guys knew that. Parfait. Est-ce que l'équipe Maurice-Lapointe est prête? Oui. Parfait. Alors, ils sont en train de prendre leur microphone, ça s'en vient. Alors, donc, c'est ça. Juste pour vous dire, je crois que la photo booth est encore en train de fonctionner, donc si vous voulez prendre des photos, il n'y a pas de problème. Portez attention au chronomètre qui est juste là. Pay attention to the timer that's over there in the corner so that you know that you have 10 minutes, and when I get up, there's only 1 minute left, so that you guys know you have a visual effect. You feel my presence, you're like, oh, I gotta get out. So... Alors, Maurice-Lapointe, ça s'en vient? Marc-André? Ah. OK. Marc-André, as-tu un autre trivia à poser à la crowd?
Ben, moi, je vais poser une question. Qu'est-ce qui est plus vieux? Which one is oldest? Sharks or dinosaurs?
Sharks. La sœur répond sharks. C'est ça?
Effectivement. Yes, sharks are older than dinosaurs.
Wow, OK. Oh, yeah, it is, yeah. Wow, ça c'est intéressant. So that's interesting. Sharks are older than dinosaurs. Wow. I think it's time for them to go. I'm just saying. I'm joking. I love sharks. I love when they take a sample out of me. It's awesome. Yeah. Okay. So, let's see here. Okay, alors un petit peu de temps encore. Okay, which underwater mountain range is the longest in the world, stretching over 65,000 kilometers? The longest.
Would it be near the Mariana Trench?
It's called the Mid-Ocean Ridge. Don't ask me for the location, I have no idea. But that's what it said here. Let's see here. OK. Est-ce que ça va, Maurice-Lapointe? Ça fonctionne? Parfait. Maurice-Lapointe s'en vient sur la scène. Bravo.
Test. Oh, parfait. Donc, salut tout le monde. Nous, c'est une équipe de Maurice-Lapointe à Ottawa. On fait partie de la catégorie des robots autonomes. Ici, aujourd'hui, on vous présente notre projet Aqua Scout. Donc, pour débuter, la rivière des Outaouais, comme on peut voir ici, donc la rivière des Outaouais est 1200 km de long et couvre un bassin versant de 146 000 km². Donc, toute la zone ici, toutes les rivières, tout l'eau se verse dans la rivière des Outaouais, donc the Ottawa River. Tout se retrouve à un point ou l'autre dans cette rivière. Donc, une recherche effectuée par Ottawa Riverkeeper a classé la qualité d'eau de la rivière comme C-. Et ceci est inquiétant parce qu'il y a plus de 400 espèces mammifères, oiseaux, poissons, tout qui occupent la rivière. Et donc, il y a aussi 2 millions de personnes impliquées. Donc, toute la zone, ça sert les communautés des communautés de jusqu'à 2000 personnes. Donc, de plus, la municipalité d'Ottawa utilise la rivière en tant que d'eau potable. Donc, c'est un risque pour l'eau potable d'Ottawa, de la ville d'Ottawa.
Alors, le problématique, c'est le rivière d'Ottawa a une très dégradation du qualité d'eau. Et l'organisme comme le Ottawa Riverkeeper fait des investigations sur la qualité d'eau. Cependant, ces investigations de surveillance de l'eau, ce n'est pas constant ou continu, alors c'est seulement une fois par mois ou environ. Et par conséquent, si les investigations ne sont pas constantes, on ne peut pas documenter les investigations sur l'eau.
Donc, comme l'a dit Jackson, donc les méthodes courantes pour la surveillance de la qualité d'eau sont effectuées par des petites organisations. Donc, c'est à base de bénévoles, et donc il y a 4 organisations ici, c'est tout ce qu'on a trouvé. Donc, la plus grande, c'est Ottawa Riverkeeper. Eux, ils ont 90 bénévoles. Donc, pensez-vous, il y a 90 bénévoles pour faire un suivi de la qualité d'eau dans toute la région. Donc, c'est 146 000 km² qui doit être couvert par 90 bénévoles. Ce n'est pas suffisant et il n'y a pas assez de suivi là-dessus.
Alors, notre système de surveillance, il permet de surveiller... Alors, notre système de surveillance permet de surveiller la qualité de l'eau de la rivière continuellement et son coupure. Et notre but aussi, c'est de réduire fortement l'intervention humaine et en créant une base de données où tout sera centralisé et disponible.
Donc, notre produit se compose de 3 parties. Donc, il y a un robot elle-même. Il y a des robots elles-mêmes qui ont les capteurs et ont des espaces pour prendre des échantillons d'eau qui sont destinés à des analyses approfondies dans les laboratoires. Donc, il y a seulement quelques données qu'on peut prendre sur place comme le pH, la turbidité, le niveau d'oxygène dissous et la salinité. Donc, il y a aussi des analyses d'ADN et de métaux lourds qui ne peuvent pas être faites sur place. Donc, on veut ramener des échantillons d'eau pour les faire dans un laboratoire par des professionnels. Il y a aussi une station de recharge afin que le robot puisse se recharger et continuer son trajet. Il y a aussi une petite application IA qu'on veut concevoir, donc, qui implémente l'IA pour analyser et pour créer des graphiques et enregistrer toutes les données. Donc, il y a un petit exemple ici, mais on veut être capable de suivre le trajet du robot, voir les données en temps réel et aussi avoir des alertes. Donc, il y aura des alertes quand il y a des anomalies afin de faciliter, de trouver où se trouve la pollution. Donc, si dans une semaine ou 2 semaines ou même un mois, le pH dans cette région-ci saute, il y aura des alertes. Et puis, on pourra faire un suivi sur qu'est-ce qui fait sauter là. Pourquoi il y a autant de pollution et pourquoi le niveau de pH augmente. Donc, c'est juste une petite animation, le bateau rentre dans la station de recherche.
Alors, pour les objectifs étendus, notre but final sera d'être capable de couvrir toute la zone de Ville-Marais à Montréal, donc sur une zone de 500 km, avec une flotte de 10 robots et de 10 stations. Et donc, chaque robot pourra faire le suivi de 10... chaque robot pourra faire le suivi de 50 km. Et voici à quoi ça voudrait ressembler. Donc ça, c'est juste une plus grande image que la dernière fois. Donc on aura des points de contrôle où le robot va se déplacer. Et environ quand on aura fini, quelqu'un va prendre le robot et va l'amener à la station au départ.
Oui, donc ça permet de réduire l'intervention humaine. Au lieu de 90 bénévoles, 10 bénévoles pour couvrir tous les 500 km.
Sur notre robot, on aura 2 types Diab. Il y a à bord et un qui est off-board. Ça sera dans le cloud. Pour IA qui sera à bord, ce sera pour les actions qui ont besoin d'une réaction immédiate. Ça sera pour les actions comme détection des objets, analyser des données pour voir s'il y en a des fausses données et refaire les mesures. C'est aussi indépendant du réseau. Donc, s'il y en a des zones où il n'y a pas de réseau, le robot pourra naviguer autonome. Et pour l'IA off-board, ce sera des modèles plus puissants pour analyser la base de données. Ça sera plus ça va économiser sur la batterie du robot. Et aussi, on pourra faire des mises à jour constantes au modèle pour avoir la plus puissante performance des analyses. Pour l'IA à bord, ça va marcher comme les entrées des capteurs, des caméras. Après, ça va être traité. Et après, c'est la sortie, les actions. Pour l'off-board, ça sera la réception de données, après traitement sur le cloud, les analyses de données et tout ça. Après, il va envoyer ces données à l'interface utilisateur et enregistrer les données à la base de données. Oui.
Alors, pour notre ligne de temps, on commence avec un bateau qui aura une GPS et une pompe d'eau pour l'échantillon. Et on aura aussi les capteurs simples pour le pH, la salinité. Et pour notre deuxième étape, on a une station de recharge qui charge le robot avec un panneau solaire et un système de sécurité. Et pour notre troisième place, on a le système de communication avec le 4G, avec une carte SIM qui communique avec le robot à une grande distance. Et on aura une application de IA, comme Abdo a dit. Et pour notre prototype final, on a une Raspberry Pi pour l'application IA.
Alors, concernant notre objectif financier, premièrement, nous voulons offrir plusieurs données, dont le pH, la salinité, la température, et l'oxygène dissous et la vitesse du courant, car ces données sont les primordiaux pour connaître la qualité de l'eau directement et avoir une idée. Et ensuite, notre but est juste de récupérer le coût d'investissement et de débarrasser le coût opérationnel. Donc, pour les organismes, tout sera gratuit, mais on voudrait récupérer le coût d'investissement que le robot nous coûtera. Et également, les échantillons d'eau nous permettront d'amener ces analyses en laboratoire pour pouvoir les analyser en laboratoire professionnel.
Pour nos publics cibles, on a la municipalité de l'Ottawa, le gouvernement provincial, l'organisation à but non lucratif comme Ottawa Riverkeeper, les Amis de la rivière Gatineau, etc. On a aussi les chercheurs universitaires et chercheurs indépendants. Pour le moment, on a contacté l'Ottawa Riverkeeper et il nous attend pour faire une présentation pour eux.
Pour les résultats et attentes, alors premièrement, on voudrait avoir une collecte programmable. Donc par exemple, à tous les 5 km ou à toutes les 30 minutes, on voudrait avoir une collecte, on voudrait le programmer nous-mêmes. Ensuite, on voudrait avoir un taux de fiabilité de données élevé et une surveillance continue de 50 km. De Harper à Gatineau, on va commencer par là parce que c'est là où nous on habite. Et aussi, pour les objectifs étendus, détection de métaux lourds, il y a capable d'identifier des anomalies, d'éviter des obstacles, une surveillance continue donc de toute la rivière de 500 km et un taux de fiabilité très élevé de 98%.
Les impacts que notre projet va faire, c'est la santé de la rivière. Il va détecter la pollution immédiatement, en temps réel. Aussi, il va suivre la biodiversité et il va s'assurer que tout va bien. Aussi, on va démocratiser les données. Ça va être gratuit au public pour encourager toute recherche universitaire, ou académique ou professionnelle. Aussi, ça va optimiser les ressources, moins de bénévoles, moins de coûts. aussi plus grande surveillance de la rivière.
Et donc, la rivière des Outaouais est très similaire à beaucoup d'autres rivières. Donc, ici, c'est 3 exemples. Donc, ça sert un nombre similaire de personnes et ils agissent comme les mêmes fonctions, donc des fonctions d'industrie, d'eau potable et des écosystèmes. Donc, c'est 3 d'autres exemples. La rivière d'Ottawa, c'est seulement un parmi plusieurs.
Alors, pour les avis des professionnels, nous avons Madame Isabelle Lavoie qui nous a recommandé de renforcer les mesures de sécurité pour prévenir contre le vol et le vandalisme grâce à notre station de charge qui, elle, sera munie d'un code. Ensuite, nous devons juste collecter davantage d'eau pour améliorer la fiabilité de l'analyse de l'ADN environnemental, limiter les risques liés aux contaminations, atténuer l'impact des courants marins et réduire l'impact du trafic marin. Alors, juste avant, si vous avez des questions, je voudrais juste remercier notre accompagnateur, M. Rabat Farez. Également, nous voudrons remercier Madame Sandra pour nous avoir accompagnés durant ce voyage, Monsieur Jeff pour avoir pris en charge tout le voyage et également le CEPEO également qui a organisé le challenge bleu brillant la semaine dernière à Ottawa. Merci.
Merci beaucoup. Y a-t-il des questions?
OK, parfait. Merci, l'équipe Maurice-Lapointe. OK. All right, now I see that we're a little drowsy a little bit, so everybody should get up. We're just going to, wiggle a little bit, just to, get the cobwebs out a little bit. Okay, I see this side is standing up, but what's going on over there? No one's standing up over there. What's going on? Come on. Let's get up. No, let's get up. We need to energize. Come on. Okay, so we're going to move side to side just like this. There you go. Just like a jellyfish. All right, and now we're squid. All right, there you go. You guys feel energized? No, you're not energized because you're not eels. You're squids. All right, there we go. Okay, and then we finish the thing with fish face. All right, perfect. Marc-André, I enjoy the fact that you're doing it too at home. That's awesome. OK, so on a l'équipe Maurice-Lapointe 2. Alors, si vous êtes prêts, embarquez sur la scène. OK. Marc-André, est-ce que tu as une petite joke de papa?
Une petite joke de papa?
Ouais.
Oui, je devrais être capable de trouver ça, une petite joke de papa.
OK. Mais garde-la, parce que Maurice-Lapointe 2 sont prêts maintenant. Alors.
OK, je vais regarder tantôt.
Ah, non, OK, ils ne sont pas prêts encore. Vas-y.
OK. Allons-y avec. Attends un peu, on va essayer d'en trouver une qui fait du sens. Ah oui! Comment est-ce que les océans disent bonjour? How do oceans say hi?
They wave at each other.
They wave.
OK, maintenant, est-ce que Maurice-Lapointe 2, on est prêt? Oui, parfait. Alors, la scène est à vous.
Bonjour. Okay.
On est prêt? OK. Bonjour à toutes et à tous. Nous sommes l'école secondaire publique Maurice-Lapointe d'Ottawa, Ontario. Et aujourd'hui, nous allons vous présenter notre projet Hydrovert Outaouais dans le volet d'énergie renouvelable. Les membres de l'équipe, on a Angélica, on a Lam, on a moi, Ethan, on a Lena, Sarah et M. Farez, notre mentor du projet.
Alors, lors de notre projet de recherche, on avait constaté que les barrages situés sur la rivière des Outaouais fournissent une énergie qui est très efficace, mais qui ont malheureusement un impact très négatif sur les écosystèmes aquatiques, notamment chez les poissons. Et d'après la Fédération canadienne de la faune, ils ont mentionné que ces barrages entraînent une mortalité très élevée chez ces poissons, comme par exemple, il y a l'anguille d'Amérique, désolé, qui a un décès jusqu'à 99% en Ontario. Et c'est principalement en raison de la perturbation des voies de migration ainsi de la passage des poissons dans les turbines. Et cela nous a montré ou donné une opportunité de développer une solution qui est renouvelable, qui est efficace et qui est innovante, qui va combiner la production d'énergie ainsi qui va protéger la vie marine. La question clé qu'on s'est posée, c'est comment est-ce qu'on pouvait développer cette source d'énergie qui est renouvelable, efficace, et qui va éviter la pollution, ainsi que qui va protéger la vie marine.
Donc, voici notre solution technique. En utilisant le processus de design et Scamper, on a développé un système énergétique qui combine l'énergie hydroélectrique, solaire et hydrogène. Donc, en regardant l'image, on peut voir les turbines de Gorlov. Ils sont stables, sécuritaires pour les poissons et efficaces dans les courants forts. Les panneaux solaires augmentent la production énergétique et les fleurs ajoutent à l'aspect esthétique. On va utiliser qu'un seul côté de la rivière pour laisser passer les bateaux, d'autres transports et minimiser notre impact sur l'écosystème marin. En regardant cette image, on peut voir que les turbines vont tourner de manière à détourner les poissons et les protéger. Voici nos propositions des ancrages et on va laisser aux ingénieurs et spécialistes à choisir celui qui leur convient le mieux.
Notre solution énergétique consiste de construire une centrale d'hydrogène aux alentours de nos turbines. Le processus commence bien sûr par nos turbines qui génèrent l'électricité à partir du mouvement. Ce courant électrique va alimenter un électrolyseur. L'électrolyseur sépare essentiellement l'eau en hydrogène et en oxygène gazeux. Nous, on va capter cet hydrogène et le stocker dans des réservoirs à haute pression. On prend cet hydrogène ensuite et on les fait passer par une pile à combustible. La pile à combustible, elle fait l'inverse. Elle combine l'hydrogène avec l'oxygène de l'air, puis forme de la vapeur d'eau comme seul sous-produit. Donc, aucun gaz à effet de serre. En même temps, l'hydrogène, on prend ses électrons, donc on crée un mouvement d'électrons, donc l'électricité qui va alimenter la ville, ses infrastructures quelconques. Voici un schéma pour mieux visualiser notre processus. Donc, notre station sera près de nos turbines, puis notre système de gestion d'énergie et la ville, bien sûr. Puis voilà une petite maquette qu'on a construite, mais malheureusement, on n'a pas pu la porter. Je ne pense pas que la vidéo fonctionne, mais on a créé aussi un SketchUp pour visualiser encore mieux. Mais...
Okay. En matière de rendement, le rendement de ces turbines est calculé par une fonction qui prend en compte la vitesse du courant, la surface balayée et le coefficient d'efficacité. En jouant sur des endroits stratégiques, on peut atteindre une efficacité qui permet de produire jusqu'à 7 kW d'énergie par jour et par turbine. Avec ce rendement, l'utilisation de 17 à 30 turbines pourrait permettre de produire jusqu'à 50 kg d'hydrogène par jour. si on compare le rendement de nos turbines à celui des infrastructures hydrauliques présentes actuellement, on voit qu'ils présentent plusieurs avantages. D'abord, ils ne nécessitent pas de grands barrages ou de grands espaces, ni de chutes d'eau importantes. Ils n'utilisent que le courant et ne demandent qu'une exploitation partielle du débit.
OK, donc on a reçu beaucoup de feedback sur notre projet. Notamment, on a eu une rencontre avec Madame Sophie Duchesne de l'Institut national de la recherche scientifique. Elle est une professeure chercheuse en hydrologie et les infrastructures urbaines. Elle nous a dit, elle nous a donné quelques aspects, quelques astuces sur le projet, dont comment on va attacher les turbines afin de les stabiliser et que le transfert d'énergie de l'hydraulique à l'hydrogène, ça peut entraîner des pertes d'énergie ainsi que des pertes de revenus. Donc, on doit garder ça en tête. Aussi, les filles ont rencontré Roya, une élève de génie électrique à l'Université d'Ottawa. Elle nous a donné quelques commentaires positifs en étant une observatrice extérieure. Elle nous a dit que c'est quelque chose de très innovant et quelque chose qui n'a jamais été vu auparavant. En conclusion, notre projet consiste d'une énergie renouvelable qui va protéger les poissons, utiliser seulement une petite propriété de la rivière et permet de stocker et produire de l'énergie efficace. On a une approche hybride, donc l'hydroélectricité, l'énergie solaire et l'hydrogène en utilisant les turbines de Gorlov, ce qui permet de créer un système efficace et respectueux de l'environnement. Enfin, les clients locaux, comme les musées, les quartiers et les écoles, peuvent profiter d'un marché de l'hydrogène vert en pleine croissance actuellement, dans un site peu urbanisé avec des courants rapides, qui sera adapté à l'hiver et nécessite un endroit qui est proche d'un centre d'hydrogène. Voici notre logo qu'on a fait avec tous les membres de l'équipe. Merci. Avez-vous des questions? Oui, Monsieur Jeff. Oui, donc la semaine passée à l'Université d'Ottawa, lors de notre discussion avec les juges, ils nous ont demandé la même question. Donc, ils ont précisé des bûches. Donc, premièrement, les turbines vont être ancrées solidement. Et puis, elles seront dans des zones peu urbanisées, donc il y a peu d'activités humaines, mais on aura de la supervision de la... donc, il y a des personnes qui vont vérifier régulièrement les turbines, s'il y a quelque chose.
Et puis, nos turbines sont grandes. Il y a beaucoup d'espace entre les hélices, donc je ne pense pas que les bûches vont être un grand problème.
Ça n'a pas répondu à la question.
Merci Maurice-Lapointe 2. Et merci Jeff d'envoyer des questions. Une chance que tu es là, sinon il n'y aurait pas grand monde qui a des questions. Thank you Jeff for all the questions you're asking. Because there's not a whole lot of questions in the room. Marc-André.
Oui.
How are you?
I am very good.
Okay, perfect. All right. So before we move on to the next team, which is Jackson's team, are they here? Do you have a trivia question for us, Marc-André?
Well, I have a question. I have a trivia and also, well, it's not a trivia, it's a fact. And then I have a question for you.
Go ahead.
Did you know that dolphins have names? So they name themselves by whistling and doing all what they do, right? So
You're
here's
jo-
the catch. If you would be a dolphin, what would you like to be called in their language?
It would be right.
And I'm asking everybody in the audience as well. What would you like to be called?
I should ask them to shout out the dolphin names. Shout out your dolphin
There you
name
go.
in the room. Come on. Don't be afraid. Shout it out. I'm right here. Okay, we got Iggy. Another name for a dolphin? E. Okay. The other dolphins are sleeping. That's what's going on, Marc-André. They're all like dozing off, enjoying the warm ocean and whatsoever. Yeah. All right. So it looks like we're going to have Flintstone Explorers presenting. Okay. So we're going to keep talking together until they're ready. So if you indulge me, guess what? I have a dad joke.
Way!
Yay, dad jokes are so awesome. I'm saying dad joke, Jeff. Dad. Okay, so why did the octopus cross the road?
Because he needed to.
To get to the tentacle side. Oh boy. Poor children who have to endure that as the dad. Oh, I got a good joke for you, son. Yeah. Okay. Okay, so Flintstone, you're still getting ready. So, Marc-André, you have a French dad joke for us?
Yes, I do.
Okay.
Pourquoi est-ce que les requins nagent dans l'eau salée?
Je ne sais pas.
Parce que le poivre les fait éternuer.
For the English people in the room, why do sharks swim in salty water? Because pepper makes them sneeze. All right. So there you go. All right. So Flintstones, are we ready, Flintstones? Are you guys ready? Not yet? Okay. So we have time for one last. Why do divers dive in the ocean from the backside? Because if they go in the front side, they dive in the boat. All right. I think that was a favorite in the crowd, Marc-André. Did you hear all these people laughing? That was awesome. You missed it all,
I think they're
buddy.
just getting tired.
Tu l'as tout manqué. Le monde s'est mis à rire, ça tapait ses jambes, c'était incroyable. C'est fou. Okay. All right. So, let's go with another trivia here. Okay. Oh, wow. I didn't know that. Sound travels faster in water than in air. What is the name of the specific layer of the ocean where sound waves can travel thousands of miles? The Midnight Zone? No, it's not. It's called the SOFAR channel, the Sound Fixing and Ranging Channel. All right, so Flintstones, we're ready? Yeah, perfect. So the stage is up to you.
Hello, I'm Michael. I'm Mason. I'm Neelan. And we are the Flintstone Explorers. It covers 71% of our planet. It is home to most of the Earth's biodiversity. And 80% of it is a total mystery. However, the ocean is very difficult to explore. We need expensive equipment such as ROVs, AUVs, boats, and special sensors. We need people with special skills such as divers. It is difficult to see underwater because there's often dark and there's often a lot of sediment. It can also be dangerous to explore underwater, especially at night and during storms.
Our mission is to find an affordable way to bring the ocean to the surface for everyone.
We are currently innovating an affordable autonomous system that will collect 360-degree footage of underwater sites.
Initially, we are focusing on mapping submerged archaeological sites. We hope to create a Google-style street view of these sites so anyone can view them from a computer.
We hope this will serve as a proof of concept. We intend to use our autonomous system in many other areas of ocean research, including pollution monitoring, observing underwater habitats, and virtual reality for education and tourism.
Before we get into specifics, we would like to share the journey of how we got here.
We actually developed our project as a first LEGO League robotics competition, which challenged us to address the issue facing archaeologists right now.
We decided to focus on indigenous and underwater archaeology, as we felt these were under-researched and relevant to Nova Scotia.
As Canadians, we're all aware of the heartbreaking legacy of residential schools and their impact on Indigenous culture.
Researchers believe there may have been ancient settlements in the Broadmoor Lakes region and Cape Breton.
However, sea levels have risen over thousands of years, so many potential sites are submerged.
Because of changing environmental conditions, chances to recover and protect underwater sites are rapidly disappearing. We learned that up to 30% of underwater sites could be lost in the near future.
Our team decided to innovate a solution to these problems in underwater archaeology. We had originally planned to build an ROV and shared our vision with Dr. Catrow Robin at the Nova Scotia Museum.
She explained that the sediment disturbance from ROVs/divers disrupts visibility. Plus, with the standard underwater cameras, it's hard to see a whole underwater site.
We did some research and we quickly realized that building an ROV to solve these problems was going to be costly.
So we innovated a new design. Our design is a watertight sphere equipped with a 360-degree camera.
The sphere is weighted to sink to the bottom where it waits for the sediment to settle. Then it captures 360-degree video footage of the site.
Once the information is collected, a release mechanism drops the weight and the sphere floats back up to the surface for recovery.
We pitched this idea to Jonathan Kite, a senior underwater archaeologist. He validated that this tool would be excellent for documenting known sites without disturbing them.
His one critique was that most underwater surveys are done along transect lines. We plan to use multi-sphere deployments along these lines to address this issue.
Our prototype was made using acrylic half spheres, but assembling it wasn't easy.
And our first test, let's just say, it was a little leaky.
A little? It was an aquarium.
We needed a fix. We met with Dr. David Barclay at Dalhousie University. He uses deep-sea spheres that cost $40,000.
That is slightly out of our budget.
Dr. Barclay advised us to switch from a round O-ring to a flat rubber seal for better waterproofing. We applied his advice to our design. Judges, meet our prototype, the Barney Rubble.
Barney was assembled for only $586.39. Once he was built, it was time to start testing.
We took Barney to the lake, breaking through the ice and braving the cold.
One engineering challenge was weight. We saw that it took exactly 33 pounds of rock to overcome the sphere's buoyancy and sink it.
We also ran into a condensation issue. We solved that by assembling the sphere in a cool, dry environment, aka the car with the air conditioning blasting, to remove moisture before sealing it.
After much testing, it worked. Here's a clip of our preliminary 360-degree footage from the lake bottom.
Just click it again, maybe it'll play that way. Oh, click the back button. We continued with our testing, but the cold Nova Scotia winter slowed us down a little.
Especially when we had to cut through 16 inches of ice for more depth testing. Much to our disappointment, after cutting through the ice, we're only in 15 feet of water.
We tried again, this time braving wind, waves, and frigid temperatures.
This time we dropped our sphere in 40 feet of water, and it survived. We then had an opportunity to meet with Jonathan Kite and David Karen, who both are archaeologists at Stantec who specialize in underwater archaeology. They were very interested in our idea. And right now, 360-degree video has not been widely used in archaeology. They gave us lots of feedback. Mr. Kipping was especially excited at the idea of using our sphere to film an underwater site at night or during a storm.
Our next step was to prove our street view idea. We dropped our sphere and moved it 7 times to get footage from a number of locations.
We then took our 360-degree footage using a free software called Panui and created a street view of the shoreline at Michael's house. You can see some of the sediment has not fully settled. Here on this drop, you can see more sediment. The temperature was -1 and the water temperature was just above 0. We made my dad go in the water, and you can tell he was getting cold.
One thing we learned was that it was very difficult to establish a consistent orientation. We plan to add a compass to our sphere so that we can establish a consistent orientation every time.
After our last round of testing, we realized our sphere had some limitations. We have too much buoyancy. 33 pounds is very heavy to move around.
It would be difficult to develop a detachment mechanism to accommodate the weight.
We have not fully depth tested it yet. There is nowhere to attach sensors.
It's difficult to remove the condensation.
After doing some more research, we came upon Blue Sub Mechatronics, a Canadian company that sells subsea robotics parts and underwater components. Their parts are professionally tested and they're easy to assemble.
Using their parts, we can create a vacuum to remove our condensation issue.
We would not need heavy weights because of a lower buoyancy. We have already reached out to Blue Sub, and they were very impressed with how quickly they responded and how helpful they were. They offered us a significant discount and even gave us a donation towards our project. Although we've spoken a lot about archaeology, the Barney Rubble 2.0 can be used in many areas of ocean research.
Archaeological firms and museums to document underwater archaeological sites and create Google Street View and VR experiences.
Monitoring sea life to also study sea life, including invasive species. Environmental monitoring to study sensitive habitats and monitor pollution.
Marine services for 360-degree inspections of equipment that is offshore.
Our project, the Barney Rubble 2.0, directly supports several of the 7 outcomes of the ocean decade.
An accessible ocean. We can reduce the cost of underwater imaging by over 90% to provide access to everyone.
A healthy and resilient ocean. We can provide a non-invasive tool to monitor sensitive marine ecosystems. An inspiring and engaging ocean. We can use virtual reality and street view mapping to connect the public with submerged history and ocean life. For our future goals, we hope to obtain the funding needed to assemble the Barney Rubble 2.0. With help from Jonathan Kite, we hope to test it at an underwater site off the coast of Nova Scotia.
After we have field tested, we can then market it for more widespread adoption.
Thank you for listening.
Oh.
Video?
Where's the microphone? Our oceans are home to extraordinary life, but beneath the surface, a growing problem is spreading. According to this study, an exponential plastic production with variable global waste management has resulted in large amounts of plastic waste entering our ocean every year. As plastic breaks down into smaller and smaller pieces, it becomes harder and harder to see. We can't fix what we can't see. So we asked, what if we could see ocean pollution better? We created a stationary, airtight underwater sphere equipped with a 360-degree camera designed to provide continuous visualization of underwater environments. It allows us to observe marine life, track visible pollution, and monitor changes over time, not just in snapshots, but as they happen. Because sometimes the most important data is what we can see. Plastic pollution doesn't just harm oceans. It disrupts ecosystems, threatens marine life, and impacts all of us.
Our mission: find an affordable way to bring the ocean to the surface for everyone.
We hope to collaborate with local ocean experts and organizations, working together to better understand and protect marine environments. Because protecting our ocean takes all of us.
Wow. Thank you, Flintstones. All I got to say is yabba dabba do. I don't know if you guys felt that, but that was something, okay? All right, how about we give a great round of applause to all our young innovators here that gave us hope. Like, my gosh. Truly, all of you have moved me. This is my first participation in Brilliant Blue, and my gosh, I am amazed by the young minds that we have here. It's amazing. All right. So this was the last presentation for today. Yeah. Marc-André, are you crying?
I am not crying, but you know what? Mes joues me font mal. J'ai tellement souri. I smiled so much all day long that my cheeks are hurting right now. It was the awesomest day. Congratulations to everybody.
That is just the energy we needed to close the presentation today, I think. Thank you all teams for all your wonderful projects. Merci à toutes les équipes pour tous vos beaux projets. C'était incroyable aujourd'hui. OK. Alors là, maintenant, bon, c'est ça. Il est présentement, les juges vont commencer à faire leur délibération à 4 heures. The judges will start their deliberation at 4 o'clock. And by that time, it'll be, I believe it's a supper or dinner for us. It'll be the souper pour nous. So before that, Omar has asked me a really specific thing, is that we do have an anthem for Brilliant Blue Challenge. On a un thème pour... I can see the excitement here. On a déjà un thème pour le bleu brillant. But we don't have a choreography. Oh, I know you're excited. I can see it. That table over there. Where's it? We're here. Yeah, okay. I can see the excitement over there. Okay, so Neil, if you would oblige, we'll put the song up. And we're going to try to figure out a choreography for that song. Now, I am not a choreographer myself. So, I'm going to need help. So, does any of the people in the room would like to help me to create a choreography for this song, for this anthem? Anyone? Oh, I got people in the back. Okay, come over here. Get over here. All right, Marc-André, you going to help us?
Well, I'm going to try to help you, but I have a 30-second lag. So I'm going to try to look what's happening in YouTube, and I'm going to do it at 30 seconds later.
Oh, wow. Okay, I'm getting a lot more backup dancers. That's awesome. All right, cool. Good. Great. All right, wait. I'm just going to go change into my sporting attire. Get on the stage. Get on the stage.
Va danser.
Okay. So, Neil, if you'll oblige, put the song on. And we will try to create a choreography. Okay, guys? Yeah? All right.
From every coastline, every city, every school, new waves rising. Yeah, we're breaking all the rules, they see the problems. We just see the work to do a different vision. Shining, brilliant, shining blue. We are the innovators, we are the engineers. We're the scientists, silencing all the fears. We see the UN decade, we know the time is now. They ask who's gonna fix this, we're here to show them how it's more than just a project. It's more than just a prize. It's seeing the solution right before our eyes. For healthy marine life, for energy that's clean. The brightest minds the world has ever seen. We are genuine blue. We see the future and we're pulling it on through. Answering the challenge, brilliant blue. We're making our impact, showing what we can do. We are genuine blue. We innovate, we create, we solve, we empower. This is the moment, this is the mission, this is the hour. We code autonomous systems, we draw the master plan. The blue economy is rising in our hands. From the brilliant blue challenge to the labs across the sea, we are the ocean stewards for all the world to be. This isn't just a dream we're hoping will come true. It's the global force of me and you. It's more than just a contest. It's more than just a grade. It's for ocean sustainability. The promise that we made for marine energy. A vision clear and true. A global chorus shouting something new. We are Generation Blue. We see the future and we're pulling it on through. Answering the challenge, brilliant blue. We're making our impact, showing what we can do. We are Generation Blue. We are Generation Blue. They call us the students, they call us the youth. They call ourselves the architects, the engineers, the truth. From a single ripple to a tidal wave, you're gonna hear the sound we've made. You're gonna hear the sound we've made. The future of the ocean is right here and right now. We see the price of it better than our we're making our impact, showing what we can do. We are Generation solve your generation blue.
And this is how you kill a 51-year-old man. Okay. Oh, yeah? Okay. Guys, you guys are going to hate Omar for this. He's asking for the dancers to come back on stage so that Scott can film the whole thing. Yes, but I will not do it the second time. So you guys will do it. You're the stars, not me. Is that? Okay, all right, okay. So as per Omar's request, he would like to have a lot more people on stage to dance to that song. So we'll use that as a promotional video on social media, everywhere, to promote Bill and Blue, to promote young innovation. You guys can do it. As Rob Schneider said, you can do it. I do have the hat too at the same time. I just thought about that. So, come on guys, don't be shy. If a 51-year-old man can make a fool out of themselves, you can do it too, not a problem. And you don't have to be in the line, guys. Okay. You don't have to be in the line. You can be on the stage as if you were dancing in a dance or something. Because if you wait for a line, there's not going to be enough people, not enough room. So take the stage. Go, take it. Okay. All right, you know what, Neil? Let's just start the song. People will come up. Okay. Okay. All right. Scott says Omar wants them all. So every innovator, get on stage, please. Every team. Every team has to be on stage. Also, I have a small message. While the judges are deliberating, the team of Real and Blue cleanup crew will do their draw during the deliberation of the judges. So we'll find out who's the winner for their draw at the end of the day. But come on, innovators, get on stage. All of you. All of you. That's what we'll get? Okay. Look at that beautiful group. Okay. So are we ready, Scott? Okay, let's go, Neil. Let's start the song. All right, let's go.
From every coastline, every city, every school, new waves rising. Yeah, we're breaking all the rules, they see the problems. We just see the work to do, a different vision. Shining, brilliant, shining blue. We are the innovators, we are the engineers. We're the scientists, silencing all the fears. We see the UN decade, we know the time is now. They ask who's gonna fix this, we're here to show them how it's more than just We are Generation Blue. We see the future and we're pulling it on through. Answering the challenge, brilliant blue. Oh, we're making our impact, showing what we can do. We are Generation Blue. We are Generation Blue. They call us the students, they call us the youth. They call ourselves the architects, the engineers, the truth. From a single ripple to a tidal wave, you're gonna hear the sound we've made. You're gonna hear the sound we've made. The future of the ocean is right here and right now. Keep talking about generation. You see the price of it better than I do. That's because it's orange, but we blue. We're making our impact, showing what we can do. We are Generation Blue. We are Generation Blue. We are Generation Blue. Innovate.
I want to see some jumping. Come on, jump, jump. At the end, we're going to yell, we are, all right?
Generation Blue.
We are, we are. Perfect, guys. That was awesome. Thank you. We have what we got. We got what we have. I can't even speak no more. I'm so tired. So I just, Brill Blue cleanup crew just came to me and he said to reassert that you guys should send them an email so they'll be entered in the draw to win a t-shirt. If you don't have one of those, they have a lot on their table. Go get one, send them an email. You'll get a chance in a draw for a t-shirt, which will be drawn during the judge deliberation.
Can we use this dance in our YouTube video or?
Sure, yeah. It's going to be on the Grill Blue side. Yeah. So I've just been advised that supper is being served now, so you can go to the lobby, grab something to eat, and we'll be back here at 5 o'clock for the closing ceremony and the awards. So see you then. Testing 1, 2. Hello, everyone. We are finally here. Congratulations, everyone. We've made it through the day. We saw all good presentations. Everyone here actually had great projects. Everyone here is a winner just for having those great innovation ideas. Tout le monde ici sont des gagnants. Vous avez tous donné des belles idées incroyables pour améliorer notre océan et tout ça. Je tiens à préciser que les prix qu'on remet ce soir, c'est du plastique qui a été collecté de l'océan même. Donc, vos prix que vous allez gagner, les gagnants, vos trophées, sont faits en plastique repris de l'océan. Donc, for the winners, the awards that we're giving out tonight, it's from plastic that was collected from the ocean. So, it makes it a little bit more special. All right, so without further ado, let's start this thing. So, who's excited for the closing ceremonies? Okay. So it is my utmost pleasure to introduce Dr. Kent to do the closing ceremonies and declare the winners.
Thank you all. So this is the fun part for us, for the judges, where we get to speak to the truly wonderful projects that we've seen. I'm told to eat some time. I'm good at that, so there's no concerns at all. So first of all, the judges, we just convened for about an hour to compare notes and come up with our list of winners. That was really difficult. really difficult to do. A lot of teams truly excelled, and all very close to one another in their performance. Some a little better here, some a little better in that. But I really do want to emphasize that a lot of teams are in the running here for these awards. So if your team name is not mentioned, don't consider that to be a failure. It is not. It was just really tough competition and really high quality competition. So I commend the teams for that. It was a real pleasure. I actually managed to judge one of the teams finally, and it's a lot of fun. I kept hearing from the judges after a round, they're like, wow, man, I can't believe this and that. So you really did have quite an impact on our volunteer judges, so I commend you for that. Now, don't worry, everyone's going to receive some feedback on your performance, but that'll be after the fact. And what I'll take the comments in from the judges, I'll summarize those, and those will go back out. So we'll give you some feedback. But you're not looking at major weaknesses here. Like, again, you take a lot of pride in the work that you tabled today. And I may have to eat a minute or more here. So the way we're going to do this, I think you've seen this perhaps from the event materials, but we will be providing an award for each of the major theme categories, and then there'll be an overall award. So a lot of the discussion actually is then how do we compare across these categories to find that one, kind of overall winner. And we could have deliberated, I think, for quite a lot longer in terms of time, but, we do have a deadline, and it's important to work to a deadline. And I'll just give the team here another minute or two. I don't want to sound too rambly while I wait. And I am going to be sticking around a little while after the event. So if people want to teams want to reach out to me and have a discussion about, in particulars about their project, I'm happy to have a conversation about it. But like I said, we are going to give you feedback. And I really want to commend the teams for their work that they presented today. The other thing that struck me is the quality of the presence of our students in their presentations. Like if I was your age, I would have died in front of a group of judges. And really the confidence, the command of your topics was really, really evident. And again, I commend you for that. We don't even see that sometimes at the undergraduate level with students giving presentations. So it goes a long way when you can present it very professionally. Kudos. Okay. So I managed to fill 5 minutes while we're waiting, so that's awesome. What we're going to do is I'm going to announce the winner, and like I said, a member of the judging team will come up and just give a couple words about that particular project. Of course, we won't be speaking about comparisons, but just what it was about that particular student project that really stood out. So first, starting with the category Marine Autonomous Systems, the winning team is MAS 04 Exhilarating.
OK, bonjour tout le monde. Ça va être une adresse bilingue, alors français en premier. Je voulais vous féliciter, l'équipe Héritage. C'était un projet très innovatif. Vous avez planifié sur tous les côtés scientifiques, social et légal. Et il y avait un immense effort de la recherche. Alors, bravo à vous. For the English speakers in the room, a very innovative project, very well planned, scientific, social, legal, immense effort on the research, and very good industry contacts. So congratulations to l'équipe Héritage.
On to the next one? Next one? Okay, moving through the categories then. So first, a second in the spotlight for our winning team. So on to the next category, Healthy Marine Life Theme. There, the winning team was HML09, the Blue Nose Builders. Please congratulate them.
Hello, everyone. To address the real-world challenges facing our oceans, developing new technology is essential, but we must not overlook the critical role of ocean education and awareness. The Blue Nose Builder team has presented a well-planned project that is both meaningful and impactful in increasing ocean knowledge and awareness among children and the broader community. Well done to the team. We are truly impressed by your work.
Okay, another glory moment. On to the third and final category of just categories. We do have an overall winner. So for the category of marine renewable energy, team MRE05, équipe Maurice-Lapointe, numéro 2.
Félicitations à ce groupe aussi. L'équipe Maurice-Lapointe numéro 2 ont créé un concept pour une turbine hydroélectrique qui est non envahissant aux poissons. Il y avait une épreuve scientifique formidable. C'était un concept très innovatif et c'est à la pointe pour le futur des générations d'énergie renouvelable. Alors, félicitations. The Maurice-Lapointe #2 group created hydroelectric turbines for the Ottawa River that are non-invasive to fish and helps with fish conservation. It was very cutting-edge research in a field that is up and coming for renewable energy generation. So congratulations, team.
All right, cool. So finally on to the final category, and this is the overall Ecosystem Excellence Award. We spent a lot of time on this. The competition was really tough and probably ate about half our time as judges. But the winner, a drum roll. I don't know if you can hear that, yeah. And the winner, overall winner for the Ecosystem Excellence Award, MAS02, the Grammar Griffins. Congratulations.
Yeah, so I had the pleasure of being one of the judges in on their presentation, and the Grammar Griffins presented an ROV-based system to detect hypoxia thresholds as they were happening, so humans could respond accordingly. The project was honestly amazing. It blew me away. I'm a scientist who works in hypoxia. Been in this for many years and extremely impressed. And honestly, congratulations, guys. Give yourself a hand.
Would you like me to announce the judges then? So then just very quickly, we're going to hold you up here on the stage for a little longer. We just want to thank our volunteer judges as well. I'll just call you out. We have certificates, so I'll call your names really quickly. If you're in the room, just stand up and give a wave. Kerri Ellen. There she is. Thank you, Kerri Ellen. Jessica Baudet over in the corner. Thank you, Jessica. Shelby couldn't make it. William in the corner. Megan. I'm not sure if Megan's still here. Sulek. They're all down in the back. Scott Shrimp. Is he still around? we do have a busy day. I'm going to go through these quick. Shuyi. There she is. And Grace. Is Grace still here? Grace over in the corner. And me. But very quickly, judges are all volunteers. A lot of the people help here are all volunteers. And, you know, we go through a lot of effort. We're like, oh, God, pulling what little hair out I have left, you know, as we prepare these meetings. But then after you sit through those presentations and you see the projects and you remember why you signed up to do it and why you sign up again to do it. So congratulations to all the teams and congratulations to our winners. Thank you very much.
All right. Well, congratulations, all winners. So now you 4 teams have qualified for the Global. So we'll see you in the fall, right? Yes. Another hand of applause for you guys. And all of you in the crowd right now, you are winners as well. Your projects are really, really great. Keep working at them. Keep improving them. You moved me a lot. Oh boy, I'm about to cry. Omar, help me. Marc-André.
Je suis là. Congratulations to everyone.
OK, peux-tu dire des mots de fermeture, s'il te plaît, pendant que je m'en vais me...
Oui, bravo. It was an amazing day. I think each and everybody here that was here today, we had a blast with you guys. And whatever you're accomplishing now, I think is going to help in the future for everyone over here. So thanks a lot.
All right, I'm good. I'm fine. All right, cool. You guys stay on here on the stage. We're going to take a group picture. And we're going to need you guys to be here in the fall in October, okay? So thank you very much for coming to this national competition, the second for Brilliant Blue. Merci d'être venu à cette deuxième compétition nationale de Bleu Brillant. Ça nous fera plaisir de vous revoir l'an prochain. Et si vous voulez venir aussi au Globo, juste pour venir assister, voir les idées internationales, je vous invite fortement à venir voir ça en octobre. So, if you are willing to come in October to assist to the Global Brilliant Blue International Competition, just to get some ideas and connections, I strongly recommend you do it. Thank you very much. Have a great night.
CEPEO va être fier de nous. Je vais parler à monsieur. OK, au revoir.
Hello, hi, it's me again. Psych! So if the teams are interested to take a team picture in front of the banner, you're more than welcome to do it right after these guys are done. Si vous êtes intéressé à prendre une photo de groupe devant la bannière bleu brillant, venez le faire. Okay. Et aussi, on va mentionner que tous les conseillers et équipes ont leur certificat de participation. All teams and mentors have their participation certificates available. Just make sure you don't leave here without them. Cheryl, where will they be? Okay, they're going to be up front. So just stop at the desk up front, ask for your certificate. They're all personalized, all your names are on there. They're really great. And we're hoping to see you in the fall, okay? Alors, allez à la place, au bureau à l'entrée, le certificat de participation pour tous les participants. Et on se fera un plaisir de remettre ça aux étudiants et aux conseillers.